Greetings everyone, warm welcome to the lecture. So I trust everyone is doing good here. So I guess the lectures that we are doing here are helping your preparation. So here we go with the time, speed, distance, one of the important lectures. So of course it's one of the simpler lecture provided you understand it in the right sense. So definitely not maybe as simpler as the time and work what we concluded in the previous lecture. I hope everybody did the homework on the time and work lecture. Here we go. We start with time, speed, and distance. We do it in about 4 hours, maybe 2 hours now, and another video of 2 hours. Right? We try and complete it in about 2 or 4 hours time. So what I do today is, so I will talk about three important elements of time, speed, distance. So one, the relationship between these terms time, speed, distance and the questions built on it. So what we'll do is in the first 1 hour, we'll try and understand these three things. One, the relationship between them. Second one, what is the meaning of average speed? So third one, what is the meaning of relative speed? We'll try and explore these three thoughts maybe in the first 1 hour time. And the remaining 1 hour we'll try and explore, we'll try and put their applications. What we do in the second lecture is we'll try and work about the problems based on trains, how the length of the trains become important, the problems based on boats, the boat moving in the along with the river or against the river. So how those dynamics would change, problems based on races, especially the circular races, because linear is more or less so would be similar to what we'll be discussing today. So therefore we'll specifically try and take a look at circular races, and if we get time we'll also do a couple of problems based on escalators, right? So how the escalators, problem built on escalators, etc. That's briefly about how we are looking at this particular time, speed, distance, or it's spread across the two lectures. So here we go. Let's get started with the first portion of this. So as I said, maybe first 1 hour I'll keep it pretty basic because it's very important to understand these three things. Number one, relationship between time, speed, distance. Number two, so what is the implication? What is the meaning and the implication of average speed? And the third one is about the relative speed. Let's try and explore these three thoughts first. Might take about an hour or so. Depends on it. Might take an hour or so. So of course, we'll do it through examples as well. We'll understand some basics and we'll do it through an example. So here we go, friends. Let's get started. So here we go. So first, when we talk about the speed, what is the speed? Speed is distance traveled per unit time. Sure, I will not get into very grassroots basics of this because as I understand this is the 6th standard syllabus or 7th standard syllabus at the most. So we are all would be pretty comfortable with this. All right, no, so I don't have to explain too much things as to speed is distance traveled per unit time. Two things are important to us generally. All right, in our a test concept or a test perspective, speed is measured in terms of kilometers per hour. Maybe these are a couple of things that you might alert that can be little important there. Speed is kilometer per hour. Generally distance is measured in terms of kilometer, time is measured in terms of hour. All right, that could be one. Second, otherwise the unit of speed generally is measured, distance is measured in terms of meters. All right, generally the distance is measured in terms of meters per second, like meters per second. Maybe I'll let know. So this could be a little bit of importance there. So of course I'll let know if it is like US or so, they might have measured the speed in terms of miles. All right, they might have measured in terms of miles per hour or so. All right, no, so but in our context here, in the Indian context, we either talk about kilometers per hour or we talk about meters per second. We talk about one of these two things. Okay, pretty important thing. As I told you, one of the important relationship between the time, speed, and distance. So technically, all right, there are three parameters as you understood: speed, distance, and time. These are the three parameters. So one, all right, now whenever the problem is given, you need to understand that. All right, when you need to understand that what is constant here, all three won't be varying. Sure, all right, now sometimes in the intervals they may be varying, but always remember one point to be kept in mind. Okay, let's start with on an elementary note. One thing that has to be kept in mind is one of them would be constant. If you can identify what is constant, problem solving becomes easier. So that is what the relationship is. Take a look at the first one. Let's say, all right, now this is the first point I wanted to illustrate. So what is constant here? The distance is constant. If the distance is constant, what is the relationship between speed and time? They're inversely proportional. Okay, we talked about this proportionality, etc. etc. as a part of the ratios lecture. You want to learn more about this, or directly proportional, inversely proportional, what does it mean, etc. I would rather, I would suggest that please watch the video on ratios and proportions, ratio, proportion, variation. Definitely you will be able to connect with this lecture a lot better. In fact, already now I gave a heads up in that particular lecture stating that, hey, so whatever you learn in this ratio, far more elementary, and we are going to use it in time, speed, distance, time and work kind of chapter. So that's what we are talking about there. But that's what we are talking about here. Speed and time are inversely proportional to each other when the distance traveled is constant. Let me give a simple illustration only for this. I will not give illustration for other two, but let me, because first time you may be doing it, therefore I'll just give a small illustration to this. Say assume that the distance 100 kilometer is constant. Distance 100 kilometer is constant. Three types, three types of people, those who have done the journey. One person said that, hey, I will travel this particular distance 100 kilometers at the rate of 20 kilometers per hour. Say there is a one person who said that I will travel this distance at 20 kilometers per hour. What is this I'm talking here, friends? The speed. All right, one side is the speed. The other side I will write this is speed here. I'm talking about speed. The other side, let me write the time taken for the journey, therefore. Time taken for the journey. Therefore, the corresponding time taken for the journey, distance I fixed it. I fixed the distance here. Therefore, the corresponding time taken for the journey is nothing but 5 hours. All right, 5 hours. 20 kilometers per hour, that's a speed the person has maintained 5 hours. Assume there is a second person who maintained a speed of 25 kilometers per hour, maintained a speed of 25 kilometers per hour. Therefore, time taken for the journey 4 hours. All right, time taken for the journey 4 hours. Okay. The third person said that, okay, I will travel this distance at 50 kilometers per hour. 50 kilometers per hour, therefore time taken for the journey 2 hours. Look, all right, now that's what you mean by inversely proportional. I also mentioned it in the ratios chapter, isn't it? Yeah. So what is happening as the distance, as the speed is increasing, the time taken is decreasing or increasing in the reverse direction. Time taken is decreasing, right? Yeah. Okay. So what does it mean here? What do you mean by inversely proportional? I asked you to remember in the day on the day. So inversely proportional is speed into time is constant. Let's speed into, whenever the things are inversely proportional, the product is constant. Product is constant also means that they are inversely proportional. That's one other way. All these are the different ways of understanding the same thing. Product is constant. Now take a look at this. That's what you mean here. That's what you understood here. 20 into 500, 25 into 400. That's what you wrote there. So mathematically writing inversely proportional, we can also say that, okay, speed is inversely proportional to time. When, what is this constant here? The distance is constant. In other words, if there are two speeds that I am comparing, S1 by S2 will also be equal to T2 by T1. Alright, if I'm comparing two fellows, I can write it as S1 by S2 is also proportional, is also equal to T2 by T1. Okay, so you didn't understand this, let me help you. So let's call that this is S1. Well, let us say that this is my S1, this is my S2, therefore this is my T2, this is my T1. That ratio will remain same. Now look at S1 by S2, friends. Let's take a look at S1 by S2. S1 by S2 is nothing but 4 by 5, 24 times, and 25 times, that ratio, right? 4 by 5. And look at T2 by T1. T2 by T1 is also 4 by 5. T2 by T1, reverse, inverse. All right, S1 by S2, then you have to write inverse, T2 by T1, T2 by T1. Okay, now this is what I want you to remember. Okay, that's what you mean by when the distance is constant, speed and time are inversely proportional. Similarly, I can illustrate the second point. I can illustrate the second point with the same kind of numerical example. When time is constant, speed and distance are directly proportional. But however, I believe that you would have understood what I meant by this. Okay, similarly, there could be a third point here. So what is the third point? The third point is time is directly proportional to distance when speed is constant. When speed is constant. Right, when speed is constant. In fact, all three relationships come from here. All three relationships come from here. The most important of all three is the first one. The most important of all three is the first one. I'm not saying that the other two are not important. The most important, if you say that, hey, 70% of the time I'm going to use this in my problems more often than not, which means if you are solving 10 questions on time speed distance, you will come across this particular concept, or 7 instances. You come across this concept 7 instances, because generally you find in the problems the distance being the constant. Okay, let's keep this in our mind. Let's quickly illustrate this relationship. What is that we are doing here? The first point, the relationship between the time, speed and distance. There are three relationships here. Three relationships. Distance constant, then how speed and time are related. Time constant, how speed and distance are related. Speed constant, therefore how time and distance are related. These are the three propositions, right? I hope all of you are getting this. All right, let's go to the next part here. Let's take examples. Let's illustrate through this example. So before we go to the, let's illustrate example. Okay, even before you go to the illustration of the example, probably I may want you to remember these 2 points here. I'm sure all from your high school you might still remember how to get them. So one point I want you to remember is a 1 kilometer per hour. If you have 1 kilometer per hour and you wish to convert it to meters per second, I'm sure all of you would be knowing that is 5 by 18 meters per second. 5 by 18 meters per second. 1 kilometer per hour is equivalent of 5 by 18 meters per second. Hey, what does it mean? So you will convert, 1 kilometer is nothing but 1 into 1 kilometer is nothing but 1 into 1000 meters. If I were to convert this to meters, this is what you would have converted the numerator. Hey, what about 1 hour? Now 1 hour, 1 hour, an hour is nothing but 60 minutes. An hour is nothing but 60 minutes, and then 60 minutes is nothing but 60 seconds. Right now, this is what you are simplifying. Therefore, 1000 divided by 60 into 60. That's what you are trying to resolve, right? Isn't it? Yeah. So when you resolve it, this is the what results become. This result becomes 5 by 18. Other way around. Hey, what if the number is given to me as given to me as 1 meters per second? So 1 meters per second, and you want to convert this to kilometer per hour. Reverse it. All it. Therefore, it becomes 18 by 5 kilometer per hour. 18 by 5 kilometer per hour. That's how already you can convert them vice versa. I want you to be very comfortable with these two, or interchangeably using, because this we use very often in the Indian context. In our context, we kind of use it pretty often there. Okay, so one already know, so which is not generally used, pretty rarely used. Sure, if you're writing exams like GRE, GMAT may be useful. So otherwise, already know not really used in our context here. So therefore, it is 1 mile per hour is nothing but 1.6 kilometers per hour. 1 mile per hour can be converted as 1.6 kilometers per hour. You can also write this as 8 by 5, whatever the way that you write. Fair enough. All it knows. That's a point. That's a perspective that I'm talking about. Okay, all of you got this. These two are important to me. Conversion. We should be able to convert them interchangeably from meter to seconds or kilometer per hour, meters per second to kilometer per hour, or kilometer per hour to meters per second with ease. All it know. Therefore, I spent about a couple of minutes on that. Let's go to the illustration here. Let's go to the illustration. Time, speed, distance, relationship. So here we go. Let's take a look at the very first question out here. Very simple nut, or it may be class 7 kind of example, but we just look at the approach, the way we approach it. So let's see, now how do we approach this one. Two cars having speeds of 30 kilometers per hour and 45 kilometers per hour, they cover a certain distance. One of them takes 20 minutes more than the other. Of course, the 20 minutes more is the slower car has to take 20 minutes more than the other to travel the same distance. Find the time taken by the slower car to cover the same distance. Let's put it like this. Let's put it the perspective. Look, just like you learned in the time and work, like previous lecture, if you have attended my previous lecture on time and work, so there I illustrated where we talked about the time duration into the efficiency is equal to work. Pretty similar. This is exactly the same relationship I'm going to use here, friends, throughout, because I want you to try and make it one size fits all, trying to learn more things of trying to customize too many things. It is easy to remember one size kind of fits all. Most of them, it's all of them may not be possible. Most of them, sure, of course we need some customized tools because we need that speed and momentum, right? Okay, so let's take a look. Nevertheless, speed into time is equal to distance. Now what is given to me? Case 1, there is a slow train, there is a slow car, and there is a fast car. All right, there is a fast car, there is a slow car, and there is a fast car. I'm sorry, right? There is a slow car and there is a fast car. We have two types of cars here, right? Slow car and a fast car. Okay, what is that author trying to say? The speeds, or this is 30 kilometers per hour. I'm writing under the speeds, friends. The other one is 45 kilometers per hour. One is 30 kilometers per hour, another one is 45 kilometers. What did I tell you in the previous one? If the speeds are in the ratio S1 and S2, the corresponding times will be in the ratio. The speeds are S1 and S2, the times will be in the ratio T2 by T1. All right, T2 by T1. That becomes the ratio of the times. All right, that becomes the ratio of the times. So what do you have to do? Simply put, just reverse them. You write it as 45 by 30. What you are doing? Put them reverse, because it's an inverse. 30 by 45 you have 30 by 45. All right, 30 by 45. Therefore, the times will be in the inverse ratio. All right, times will be in the inverse ratio, which means if we want time 1 by time 2, all right, because speed is given to us, time 1 by time 2, that will be in the reverse ratio, speed 2 by speed 1. That's what I wrote there, 45 and 30. But it's a ratio, friends. It's not the absolute value. It's a ratio, isn't it? Therefore, what you do, simplify them. You will say that, all right, man, this is 3x, 15 3 times, and this is 2x. So which implies that in the first case, the slower car is taking 3x time. The faster car is taking 2x time. Okay, what is the gap between them? The gap between them is 1x. Nothing but x. 1x is nothing but x. In the sense, the fast, slower car is taking 1x more time. See, faster car is taking 2x time. Slower car is 3x time. Slower car is taking 1x more time when compared with what? Faster car. Now, that is what author said, equal to 20 minutes. It takes 20 minutes more. 20 minutes more, meaning what? Hey, 1x is equal to 20 minutes. 1x is equal to 20 minutes. That's what author is trying to say. All right. Therefore, what is the time taken by the slower car? I can write it here 3x. 1x is equal to 20 minutes. Therefore, 3x is equal to 60 minutes. 3x is equal to 60 minutes, or the 2x is equal to 40 minutes, whichever way that you think. All right, now either ways it is fine. So I get my times here. Okay, first question, find the time taken by the slower car to cover the same distance. We got the answer. Hey, what is the time taken by the slower car? 60 minutes or 1 hour, whichever way the answer option is represented. If it is in terms of minutes, 60 minutes. If it is in terms of hour, you would have said it is equal to 1 hour. Pretty simple one, pretty simple one. You may say that, hey, can I find the distance from here? Yes, of course, you can find the distance. Yeah, what is the distance? Either you can look at the first line or the second line to write the distance. You can look at this and write. You can look at this and you can write the distance, because it's given. Speed, time is nothing but distance. Therefore, you know, hey, what is the speed? 30 kilometers per hour. 30 kilometers per hour. I'm trying to find distance, friends. It's not that. That's not the question, but I'm just illustrating it here. Right now, 30 kilometers per hour. What is the time here? The time is 1 hour. You may say that, hey, isn't it 60 you should be writing? No, you should not be writing 60, because when the speed is defined in terms of hours, when speed is defined in terms of hours, time has to be maintained in terms of hours. Therefore, you are saying that the distance is nothing but 30 kilometers. Ensure that the units are matching, right? Your question may give the dimensions, units in various kinds of units. They may talk in terms of minutes, sometimes seconds, sometimes kilometers per hour. So whatever the units could be, but you ensure that there is a consistency in your writing. All right, while you are trying to express certain things, there is a consistency in your thinking and in your representation. Good. Okay, I guess you are getting this. This is a pretty simple one. So what I'm trying to say that, hey, this is what I want you, I should learn to use. Why? The distance is constant here. Whenever the distance is constant, speed and time are inversely proportional, because both the cars are traveling what? Same distance. Which means whenever you first look at the question, first understand that, is distance constant, is speed constant, is time constant? That's the first question I want you to ask yourself. Once you ask that particular question, rest of it definitely falls in perspective. Okay, let's take a little more examples to illustrate this point. Let's take another one. Same question here. Here we go. Let's take this. Normally, it takes 3 hours for a train to run from station A to station B. All right, station A to B. One day, due to minor trouble, the train had to reduce its speed by 12 kilometers per hour. And so it took 1 hour more than the normal time to reach the destination. Naturally, because the speed is reduced, so it is going to take more time. What is the distance from A to B? What is the distance between these two stations? All right, let's put it to the same perspective, friends. Time, or at this time. So what is given to me? Time, speed is equal to distance. Distance is constant. Distance is constant normally, because this train is moving between the stations A and B. Normally it takes 3 hours. One of the days it took 1 hour more. One of the days it took 1 hour more. So what is given to me? Normal, normal, and here it is the reduced. All right, normal. All right, one is the normal. The one is the troubled. All right, now once when it is in the trouble, when it is in the trouble. All right, now let's write it as normal. So now normal, and let's call it as the troubled season. All right, troubled times, normal times, good times, normal times, and troubled times. Like this, it has a troubled time. All right, now because of something, all right, there was a trouble, it has some troubled time. Let's write it like this. Yeah, if it is a normal situation, not a troubled situation. If it is a normal situation, what is the time taken? 3 hours. 3 hours. Keep hours in mind. All right, now what you want to write it, you can write it. There is no problem. Normally it takes 3 hours. Because of the trouble, how much time it is taking? 1 hour more. Therefore 4 hours. See, if you look at the first question, the speeds were given. In this question, what is given? The time is given. Fair enough. Whatever is given, no worries on that. Time is given, 4 hours. Okay, let's take a look at the negative. Therefore, all right now. So what is the relationship of speeds? Time and speed are inversely proportional. Therefore, you will say that the speed, the normal speed, normal time, speed of normal speed 4x, normal time through normal, no, troubled speed 3x, inversely proportion. There is 3 by 4 here. Write it in the reverse order. Write it in the reverse order. 3 by 4. But it's a relationship. It's a ratio. That's a speed ratio. Now look at that. Normally the speed is 1x more. Normally the speed is 1x more. All right, now so that's what is given. What is this value of 1x? 12 kilometers per hour. That's what is given. The train has reduced its speed by 12 kilometers, not reduced to 12 kilometers. It reduced by 12 kilometers, which means the difference between 4x and 3x is nothing but 12. That is what author is trying to say. Therefore 1x is equal to 12. right? Yeah, 1x is equal to 12. Therefore from here you will say that find the distance between a and b. You can find the distance already. You can find the distance because the speed is given in terms of kilometers per hour. Good. The time is in terms of hour. Therefore I know conversions, etc. I can do it directly. Good. All right, so what does this mean here? So all right, the destination, either you can write it here, what is 4x? X is 12. All right, therefore 12 into 4, 48. You can write it as 48, or I can write it here, what is 12 into 3, 36. Either ways it is fine. So distance, which case I should consider? Any case is fine. You can take the first case, you can multiply time into speed, or you can take the second case and you can multiply the time into speed. What is time? 3 hours. Okay, what is speed of the first case? I'm taking first case as a reference. Okay, what is speed? 48. Okay, therefore what is the distance here? Time into speed, which is nothing but 144 kilometers. All right, which is nothing but 144 kilometers. I guess all of you it is making sense. What do you mean by identifying? Two things I'm teaching you. First, identify what is constant. Second thing, identify, now see that already how the other two things are related. Are they inversely related or they directly related? Right now, that's what I want you to understand through these examples. Let's take a look at this question. Let's take a look at this question here. A train is traveling from Mumbai to Ahmedabad. Because of the technical fault, it covers entire distance at 4/5 of the original speed and reaches 2 hours late. There is a problem here. All very similar to the previous question. 4/5 of the original speed. What you do is whenever there is a denominator, some number in the denominator, assume original speed to the multiple of this 5. Original speed to be the multiple of 5. Okay, let me put it to perspective here. Don't bother. Let me put it to the perspective. So now this is given to me. What is the constant here? The distance between Mumbai and Ahmedabad is constant, whether there is a technical fault or there is no fault in the engine. So more distance remains constant. So therefore you say that distance is constant, speed into time is equal to constant. Distance, which is nothing but constant. Always identify what is constant. Therefore you will understand that the other two are whether directly proportional or inversely proportional. Let's come here. All it now. So one, the usual, all it now, the no fault, which means normal situation. One of them is a normal situation. Second one is a faulty situation. Well, right, second one has a faulty situation. There is some technical fault. Right, yeah, faulty situation. So normal situation, let me take the speed as 5x. Hey, now you may understand that why is 5x, because when there is a technical fault, the speed has become 4/5 of the original speed. So why don't you assume original speed to be 5x? That's easier. All of that's easier. Thereby calculating 4/5 of 5x, life is easier. You can write it as 4x. Easy to write fractions. All right, therefore you say that the faulty situation speed would be how much? 4x. A time, what about the time? Time will be inversely proportional. If this is this, the time will be inversely proportional. This would be 4y and this is 5y. This is 5y, which means normally the train takes 4y time. Normally it takes this 4y time. Because of the faulty situation, the speed got reduced and hence it is taking 5y time. Hey, what is the difference between them? Author has given this. The difference between them, the author has given 4y and 5y. It is 2 hours late. Therefore 1y extra. 4y and 5y is 1y extra. What is this 1y? 2 hours. This 1y is what is nothing but 2 hours. Now question, what is the question here? What is the normal time taken? Normal time taken means author is questioning what is the value of 4y. The value of y is 2. The value of 4y is 8. 8 hours. Therefore normal time is 8 hours. Normally it takes 8 hours. But this situation, the revised situation, that's a faulty situation, it is taking 10 hours. It is taking 10 hours. But the answer is 8 hours because the question is talking about the normal situation. I guess fair enough. You all got this particular point. Here we go with the CAT question, exam question technically. Let's here take a CAT question. Let's take this CAT question. Apply this, whatever the relationship. I did 3 problems. By now you kind of substantially understood how to identify the distance constant, etc. Take a minute. Take a minute. Think about this question. Beautiful question. We'll do more of the applications toward the end of the lecture. First 1 hour or 70 minutes, let me restrict it to pretty basics. Based on that concept, take out your pen, take out your book, push your pens. Always do that practice whenever I ask you to do that one odd question there, here and there. Take it seriously and practice it. Don't be passive onlooker, passive viewer. Be active. That helps. I guess you got the perspective, right? Yeah, most of you have solved it as well. Let's take a look. Let's take a look. Beautiful question. So what is happening is the distance is of course constant. You are talk. We actually analyze a constant distance. What is this? A train traveling 100 kilometer or after a train after traveling 100 kilometers develops some snag, means problem. It develops a problem, right, in the engine, and hence travels remaining distance at 3/4 of the original speed. Naturally, if you travel the remaining distance at 3/4 of the original speed, we cut down your speed. Naturally, you are going to take more time. You're going to take more time. Let me represent this first thought. Let me represent this first thought. It could be something like this. Assume that the train is moving between X and Y. The train is moving between X and Y. These are the two stations it's moving. So what happened is already it went up to A. This is 100 kilometers, let us say. It went up to A, which is 100 kilometers. It went up to A. Let's assume that it went up to A. Okay, it went up to A, which is 100 kilometers. And it went up to A and it developed some problem there, 100 kilometers, and it developed problem. Okay, so because of the problem, so what happened? The rest of the journey, that is A to Y. So here the speed here is 4x. I'm writing speed, friends. Speed here, speed is equal to 4x. You may wonder why not x, why 4x? Because I see that there's a 3/4. I already told you in the previous question, 3/4. So therefore you take it as 4x. Therefore 3/4 of 4x becomes 3x. It's easy to write. It's easy to write. Simplify your life, right? Simplify the things rather than writing too many fractions. Simplify the things. Make suitable assumptions. Anyway, you have to assume. Instead of assuming x, why don't you assume 4x, right? Yeah, okay. So therefore the speed is 4x. The rest of the distance it traveled with a speed of, rest of the distance it traveled with a speed of 3x. That's the meaning of this sentence, 3/4. All right, now look at the second situation, friends. Look at the second situation. Pretty similar, ditto, mirror image, but the problem did not occur at A, the problem occurred at B. All right, now this is point A, no doubt, this is the point A, and this is point B. Now that's what he's saying. If the engine develops the snag problem 30 kilometers further, which means at B, 30 kilometers further. So this is 100 kilometers. That is between X and A, and this is 30 kilometers. If the problem develops after this, which means what is that author trying to say? If S speed here is 4x, the speed here is also 4x, but the speed here is going to be 3x. The speed here is going to be 3x. Right now, that is what author is trying to say, because the problem occurs at B, or the problem starts at B. So therefore, from there, the speed is going to be 3x. Now, okay, let me just copy this point here. Let me copy this point here. Simply let me copy this point B here as well. So in the earlier case, what was the speed maintained, friends? The speed maintained here was 3x because the problem started at A itself. But here the problem started at B, but earlier the problem started at A itself, therefore it was 3x. Hey, what is B to Y? The speed maintained B to Y, that is also 3x. All right, that was also 3x in the earlier case. Therefore, now look at this. All right, now look at this. This is what all the analysis they want to do. You may feel like a distance is constant, correct? But how do I do this particular problem? The distance, if I say x to y is the common distance, no? So you don't have to take x to y common here. Author never meant that, okay, you got to be taking x to y here. So what author meant is this. Now look at this. Hey, this is 4x. All right, now this is 4x. This is also 4x. Therefore, there will not be any time gain or time loss. When the train is traveling between X and A, neither there is a time gain nor there is a time loss. There is nothing. All right, there will not be a gain nor there will be a loss. Now look at that, the difference. Okay, here it is 3x and here also it is 3x, which means B to Y both the times. All right, be it the first case, let me call it as the case 1. Let me kill it as the case 2. Be it the first case or be it the second case, the speed is same. Speed maintained between B and Y is same. Therefore, the time taken also should be same. Time taken also should be same. Good. All right. But what is the gap that's coming here? Now here the speed is 3x. Here the speed is 4x. Which means if there is any time gap, it is because of the distance AB. Therefore, I need to analyze between AB. That is the point we are trying to make. The distance constant, but the time speed is not constant, is between AB. Therefore, what is important to me after doing this question is, hey, you got to do the micro analysis between the distances A and B. That is what the question is about. Okay, so what happened there earlier? Usual time of travel is T. Let us say that usual time of travel is T. Good. Okay, so how much time it took more earlier? 37 minutes more. 37 minutes more. 37 minutes. Usual time of travel between X and Y is T minutes, let's say. How much time it took? 37 minutes more. Very good. In the second case, how much time it is taking? 25 minutes more. 25 minutes more, which means it is saving. It is saving. Hey, how much time it is saving? It is saving a time of 12 minutes. There is a saving of 12 minutes. If you say that, hey, how come it is saving 12 minutes in the second case? Because of the speed. Earlier it maintained a speed of 3x. Now it maintained a better speed, which is 4x. Because it maintained a better speed, naturally, all it has saved some time. Between the two cases, it has saved some time. So how do you analyze this? Distance AB is constant. Therefore, you write the same thing. Speed into time is equal to distance A. Which is this distance AB? Yeah, what is this particular distance? 30 kilometers. What is this distance? 30 kilometers here, friends. 30 kilometers. Therefore, you are analyzing this particular distance, which is 30 kilometers. Good. The speeds are given. Yes, between the case 1 and case 2, the speeds are given. Hey, what is the case 1 speed between AB? 3x. I circled it, 3x. Case 1 speed is 3x. Very good. Hey, what is the case 2 speed? 4x. I've circled it, 4x. Similar to the previous question. Therefore, hey, what about the time? Time will be inversely proportional. Therefore, 4y and 3y. 4y and 3y. Okay, so this entire thing is 4y, right? Isn't it? This entire solid? No, so whatever, this is 4y and 3y. If you say that, okay, whatever you do the micro analysis, you know that the distance gap between them is how much? 12 minutes. Therefore, what is the gap between 4y and 3y? That is 1y. Yeah, what is this 1y? This 1y is equal to 12 minutes. This 1y is equal to 12 minutes. Okay, what does author is interested in? Find the usual speed of the train. Friends, what is the usual speed? You need to be careful. Usual speed is 4x. Solid. When there is no problem, the train travels at 4x. Author is asking that, why don't you tell me the value of 4x? That is the author's question. Author is interested in 4x. Okay, how do I find this 4x first of all? So for that, I need to find the x first of all, isn't it? I need to find the x first of all. Good. So whatever that particular one, how do I find it? What is the distance? What is the no? So what is the distance? When you want to find the speed, what is speed here, friends? Distance divided by time taken. Speed is nothing but distance divided by time taken. If you want the original speed, if you want this original speed, s is equal to 4x, then take the original case, which means take the second case in which there is already 4x as the speed. You don't have to find the x. No, s is nothing but 4x only. If you take the second case, the speed is automatically 4x, and author is interested in that usual speed. So therefore, use the second case. Use the second case means what? Use the time under the second case. Hey, what is the distance? Distance is 30 kilometers. Be it first case or second case, distance is 30 kilometers. But the time, take this 3y. If you take this 3y, automatically you will get the value of 4x corresponding. Hey, what is 3y? Y is equal to 12 minutes. 3y is equal to 36 minutes. 3y is equal to 36 minutes. Okay, generally the speed will be in kilometers per hour. Answer options will be there for this question. That would be in kilometers per hour, but you are writing it in kilometers per minute. Why don't you write it in kilometers per hour? Convert it and write it in kilometers per hour. 30 divided by 36 by 60. Alright, that is what you write it as kilometers per hour. Now this has become kilometers per hour. Therefore, the speed is equal to, alright, that's the original speed. Speed is nothing but, therefore you would say, therefore the speed is nothing but, alright, the original speed is nothing but, simplify this, 30 divided by 36 by 60, alright, which will become 50 kilometers per hour. That is the original speed. Original speed is actually 50 kilometers per hour. So if you want the original speed, take the second case directly. If you want the revised speed, take the first case. That's it. That's a pretty simple one. So which means already you don't have to draw so much of diagram, etc., etc. Once you understand this particular question, trust me guys, it wouldn't take more than 2 minutes to solve this issue. It will definitely not take 2 minutes to solve this issue. Hey, what is the difference between your foundation questions? For example, this foundation question also same. You wrote the exactly similar elements, speed and time, etc. But the point is the entire distance was taken into consideration. But here what is that you are doing? What is the cat question is about? He's saying that, okay, take a part of the distance into consideration. Analyze only between A and B. That is the difference. That is the difference. In sense, take part of the distance. That distance is constant. Do the analysis under AB, under AB, not between X and Y. Do that under AB. Once you do the same thing under AB, the relationships, etc., remain same. But the point is what? Look at that particular, now look that portion AB. Don't look at the complete portion X and Y, because it all remains same between X and Y. Between B and Y, the speeds are same. Therefore, this 12 minutes gap is definitely not because of the distance traveled between B and Y. It is also not because of the distance traveled between X and A, because it's both are 4x and 4x. Then where is this 12 minute saving is coming? That is between 37 and 25. Where is the 12 minute saving is coming when you subtract? It is because of this. On one hand you have 3x, on the other hand you have 4x. The speeds changed between A and B, which is a distance of 30 kilometers. That has a distance of 30 kilometers. This whole problem is because of that A and B. If you understood this, I'm sure that, okay, you now got the actual concept behind, the actual application behind the concept. What do you mean by when distance is constant, the speed and time are inversely proportional? This is what it technically means, this kind of questions. Okay, we'll do some similar kind of questions towards the end, or let's similar kind of concept. I'll come back to it. Let's go to the second point of discussion, relative speed, sorry, average speed. Let's go to the average speed. Well, let's go to the second point of discussion, which is an average speed. Average speed. Okay, now listen to me, friends. Average speed is nothing but average speed. Average speed is nothing but weighted average of speeds. That's all I want you to remember. Not the simple average. Average speed is weighted average of speeds. In sense, okay, if the given to now wait, what is weighted? That's all you got to remember. Remember it like this. Weighted average we already talked. We already talked weighted average. Allegation is a classic example. Through the allegation, we were talking weighted averages only, ratio of the weights, etc. We were talking weighted average only. Through the allegation, it was weighted average. In fact, the averages chapter also, I spent some time, maybe 20-25 minutes about the weighted average. You and I spent some time there. So if there is a problem with weighted average, please take some look, some detailing about the allegation chapter. Then you will also understand a little bit of the weighted average there. The beginning part of the allegation chapter, I talk about the weighted average. Right now, that's where you can understand it. And nevertheless, most of you would understand it. It's not a big great concept. Very simple concept. Therefore, it's not very difficult to understand as such. Let's come back here. Weighted average of speeds. Average speed is equal to weighted average of speeds. Then the point is what are the weights? Then the point is what are the weights? Don't write the simple average, write the weighted average. Weighted average of speeds in the sense, what are the weights then? If you say weighted average, then there should be weights for those speeds, correct? Time becomes the weight. Time becomes the weight. All right, I'll write it here. Therefore, average speed, let me write it as speed average. All right, let me write it as average speed is nothing but S1 into T1. All right, somebody maintained a speed of S1 for about time one or T1 time. So maintained a speed of S2 for a T2 time. Maintained a speed of S3 for a T3 time. Let's say dot dot dot. Okay, divided by what? What are the weights here, friends? Weights are T1, T2, and T3. What are the weights here? T1, T2, T3, dot dot dot. All right, dot dot, whatever, but what are the weights? Now, what is the point I wanted you to remember? The time can be in the form of a ratio, the weights can be ratio. This is what I tried to tell in the beginning of the allegation chapter. If you look at the first few minutes of the video of the allegations and mixtures chapter, this is what I tried to tell there, right? So in the sense, the time can be ratio, the speeds cannot be ratio, because the speed is nothing but the qualitative aspect. Time is nothing but the quantitative aspect. How long did you travel? That's a quantitative aspect. Therefore, the time can be in the form of a ratio or a percentage, whatever it could be, but the speed has to be in the absolute terms. The speed has to be in the absolute terms. The time need not be absolute terms. Some people also remember something like this. They will also say that, hey, this is total distance traveled by total time taken. Total distance traveled by total time taken. Some people do it like this. Excuse me. Excuse me, guys. Okay, total distance traveled by total time taken. Some people remember it like this as well. No worries, absolutely no worries. That's also fine. But I want you to remember this as average speed is nothing but weighted average of speeds and not simple average of speeds. Hey, what is simple average of speeds? Simple average of speeds means you will add like this: S1 plus S2 plus S3 divided by 3. All right, that is becomes the simple average of the speeds. No, I didn't mean this. It is not about this. This becomes the simple average of speeds. What is weighted average of the speeds? You got to identify the corresponding weight of the speed. All right, that's nothing but T1, T2, T3. These are the weights. So therefore, you got to consider those weights as well, right? I hope all of you got this particular point. As I do some questions, I will brief you a little further about them. All right, let's keep that in mind. So average speed is nothing but weighted average of speeds. It's not about the simple average of speeds. If you understand that much, all right, you kind of recalled what you learned in the high school. What you learned in the high school. All right, that's precisely the words your teacher would have used. Fine, let's go here. Let's go here. Let's understand this. Let's understand this simple question. I will do 3-4 questions. By the time your understanding will be completely good. All right, it will be clear, crystal clear to you. Let's do this. And as I do this, I will also add few points to it. Okay, so first question here. Satish travels the first 6 hours of his journey at 60 kilometers per hour speed, and the remaining 10 hours at 24 miles per hour speed. Okay, miles per hour. Fair enough. What is the average speed in terms of miles per hour for the entire journey? Well, it does not matter kilometers or miles. So units are consistent. Now listen to me carefully, friends. All right, listen to me. There is a S1, all right, S1, T1. Those numbers are given to me. There is a S1 and there is a T1. There is a S2. There is a T2. All right. Now what is S1 here? Absolute value, 60 miles per hour. Don't change it. What is S2 here? S2 is nothing but 24 miles per hour. Don't change it. But what about the T times here? All right, the times here. The time first part of the journey, first 6 hours, therefore 6 hours. All right, 6 hours. The second part is how much? All right, 10 hours. Second part, all right, now the remaining 10 hours, which means 10 hours. 10 hours he traveled for, 10 hours he traveled at the different second speed. Now, what I said here, the ratio of the time periods. Therefore, should I maintain 6 and 10? No, ratio is enough. Time can be in the form of a ratio. I am good with it. Time can be in the form of a ratio. Therefore, I would say that, okay, this is 3:5. 3:5. So, therefore, how do I get it, friends? So, average speed is nothing but S1 T1 into plus S2 T2 divided by T1 T2 divided by T1 plus T2. That's a weights. T1, T2 are the weights. Put it to perspective. Hey, can I use this reduced number 3 and 5? Yes, of course. That's what I meant. That's what I meant. When the numbers become critical, this is what I wanted to use. As we go to the next problems, you will understand and appreciate why I'm telling you this. Right? Okay. Therefore, S1 and T1, that is 60 into 30. That is 60 into 30. Let me do it complete. 60 into 3 plus the next one, 24 into 5 divided by 3 plus 5. 3 plus 5, which is 8. Therefore, you are saying that 90 plus 24 into 5, 120, which is nothing but 210. Let 90 plus 210, 90 plus 120, which is 210 divided by 8. We can simplify this. This is not a problem. Let simplifying is not a problem here. So this is what it means here. Okay, my point here is what? The time can be in the form of a ratio. You can always take the ratio of the times. Let's capitalize on this. This is what I want you to understand. It is the weighted average of the speeds. Don't get the answer as, hey, yes, as speed average is equal to S1 plus S2 divided by 2. No. All right, this becomes the simple average of the speeds. In that case, you are trying to say that, okay, it's going to be 60 plus 24 divided by 2. No, this is not what I meant. Remember, it is just the weighted average of the speeds. Hey, what are the weights? The weights are nothing but time period. Weights are nothing but time period. Good, let's go here. Let's go here. Let's go to the next question. There is a person travels from Mumbai to Pune at a speed of 40 kilometers per hour while returning back through the same route. Okay, now suddenly through the same route means we are adding another dimension to this. Distance is constant. Through the same route, he returned through the same route, distance constant. See, if you look at the previous question, there is nothing about talked about the distance constant. He said that first 6 hours this is the speed maintained. All right, now so what he said there is first 6 hours this is the speed maintained, next 10 hours this is the speed maintained. That's it. All right, now that's all which has been told there. They didn't talk anything about, okay, the speed is they didn't talk about the distance constant, etc. But when you come to this question, he's adding another element to it, another dimension to do this, right? Yeah, he's adding another element to do this. What is he trying to say? Distance is constant. Now this time he's trying to say that distance is also constant because they are traveling from Mumbai to Pune and the person took the same route, returning back through the same route. Means what? Hey, in addition to whatever you understood about average speed, another point which is another point here getting added is distance is constant as well. Good, distance constant. Now therefore, now look at them, very similar to this. There is a case 1, that is a forward journey. There is a backward journey, case 1 and case 2. Speed into time is equal to constant. Into time is equal to constant. Good, friends, all right. Now, so therefore, what is the speed here? The speeds are 40 and 60. Case 1 40, case 2 60. Therefore, what are the times? All right, the times are in the inverse ratio, 40 by 60 by 40. That is 3:2. Hey, is this enough for me? Of course, it's enough. That's what I said. That ratio right here. Therefore, all right, average speed. Therefore, what is average speed? Average speed is nothing but all right now the S1 into T1, that is 40 into 3, 40 into 3 plus 60 into 2 plus 60 into 2 divided by 3 plus 2. Done. All right, now this time the time was not given, time ratio was not given because author felt that there is no need, because I'm telling you distance is constant. When I am telling you distance is constant, which means the time ratio is given to you, because all you wanted was a ratio. It is given. So when it is given, you use it. Why I should be redundant and I should talk about the time ratio? Earlier I talked about the time speed, time also, because the distance was not constant. Here it is constant. Therefore, it is a redundant information, and hence author avoided it. Author avoided it. All right, question maker avoided it. Therefore, that's what you are trying to say here. Therefore, it is nothing but 240 divided by 5. Therefore, it becomes 48 kilometers per hour. That is the average speed maintained between them. Average speed maintained between them. Good. Okay, another point here. Okay, my point is clear. Hereafter, we can write it like this, my friends. If there is a speed 1 and there is a speed 2, if the speeds you are writing it there, the corresponding times, which means I can write it like this here. Hereafter, I will write it like this. If the speeds are in the ratio of, say, speed is 40/60, time will be 1 by 40 and 1 by 60. Just I'm telling you here after I will write if there are too many speeds there, right? 1 by 40 and 1 by 60. Good, take the LCM. What is 40 and 60 LCM? 120. Well, therefore multiply throughout by 120 here. Multiply throughout by 120 here. 120 by, because you don't want to multiply by fractions. Okay, because anyway it's a ratio. Multiply by the LCM. LCM of what? 40 and 60, because they're in the denominator. Multiply by them. Therefore, you'll get the time ratio as 43 times 60 2 times. Once you get that 40 into 3, that's what you are writing here. And then 60 into 2, that's what you are writing here. That representation is also fine. Third point, when the distance is constant, All right, when the distance is constant, then the average speed is nothing but harmonic mean of the speeds. Average speed is nothing but harmonic mean of the speeds, that is S1 and S2. What is that? Harmonic mean of two numbers. Harmonic mean of the speeds. Good. So how do I write it? Harmonic mean. I'm sure right now you might remember a little bit from your progressions, APAM, GM, HM, something like that. Harmonic mean of two numbers S1 and S2. All right, S1 and S2 is nothing but 2 times of the product S1, S2 divided by S1 plus S2. Okay, we'll talk more about the harmonic mean, etc. when we do the progression chapter. For now, just put it to perspective like this. Okay, how it has to be written technically? 2 divided by 1 by S1 plus 1 by S2. This is what you would have written, plus 1 by S2. That's what you would have written, which finally becomes this. Okay, can I use this also? Yes, you could have used it here. Therefore, speed average is nothing but 2 times of what is the first speed here? 40. Yeah, what is the second speed here? 60. What is the sum of the speeds here? 40 plus 60, which is 100. All right, 100. That also gives the same result, which is 48 kilometers per hour. That also gives the similar result. All these points, when all this comes into play, when the distance is constant. Otherwise what? All right, otherwise what? We know that, okay, we know that, okay, if I know the ratio of the time taken, they acts like a weights of this particular question. Let's go further. I hope all of you got this point here. Let's go further here. Let's go further. Let's take a look at this question, friends. Let's take a look at this question. I'll give you a minute. I want you to try this now. I give all possible inputs here. Now just put it to perspective. Let's see how quickly you can put it to perspective. Yeah, I guess you got it. Let's do this. A person covers 3 different stretches of journey, 3 different stretches of equal distances. Basically, the distances are same. So distances are same. Hey, can I find the harmonic mean of 3 numbers? Yes, you can. There is no problem. Other way around is what? All right, now let's say that 3 equal distances. All right, this distance is same, this distance is same, this distance is same. 3 stretches basically. Maybe one of them is a very plain road, the other one is a very hilly road, something like that. Therefore, the speed maintained in the first interval, all right, first part of the journey is 100 kmph. Well, he maintained a speed of 100 kmph. But if you look at the second stretch, the speed got reduced. Because maybe the road is little difficult terrain to drive. All right, therefore, average speed maintained is 50. Maybe further on, it became even more difficult because probably you are hitting the hill, or a hill station. Therefore, you're almost closing, and therefore it may be becoming even more intense to drive there. Therefore, I assume that the speed has become 40 kilometers per hour. He maintained a speed of 40 kilometers per hour. Put all these three to perspective. Let's put all these three. So therefore, now, so what he wants to understand? What is the average speed for the entire journey? Don't add all these 3 numbers. 100 plus 50 plus 40 divided by 3. That becomes the simple average, right? We are talking about the weighted average. Weighted average is what we talk about. Okay, therefore, what I need to find out? I need to find out what is T1. I need to find out what is T2. I need to find out what is T3. You may wonder, how can I find it? You can find it because the distances are constant. Distances is same. Therefore, you can find it. If the distance was not same, then author would have given that particular distance. All right, author would have given that. Because the distances are same, you are in a position to find out, right? You are in a position to find out that. Okay, let's take a look here. So how do I find out? Therefore, you are given that S1 is given, S2 is given, and S3 is given. The distance speeds are given to me. That is 100, 50, and 40. Therefore, what about the times here, friends? What about the times here, friends? The times are going to be in the inverse proportion. T1, all right, the time ratio, the time T1, T, all right, these are the speeds here, 1, 2, 3. All right, now these are the speeds, technically speeds. What is the time ratio? T1, T2, T3, inverse 1 by 100, 1 by 100, 1 by 50, and 1 by 40. This would be the time ratio. Good. So what do you do? Take the LCM of the denominators. What is the LCM of the denominators? 200. Multiply throughout by 200. Therefore, multiply throughout by 200. Therefore, the ratios will start looking a little better. Right? Ratios might start looking a little better. Multiply throughout by 200. Therefore, this is 2 is to 4. 4 is to 5. So that is what you are writing. Okay, therefore you got the values of T1, T2, T3. This is T1, this is T2, second leg of the journey. This is T3. Now do what? S1, T1, S2, T2. Do that part. All right, let's do that particular part. You are multiplying this 100 with 2. That is 200. S1 into T1. You are multiplying 50 with 4. All right, which also becomes 200. Right? You are multiplying 40 with 5. That's also 200 because anyway the distances are same. No worries. Divided by what? This is all you wanted to know. 5 plus 4 plus 2. All right, which is nothing but 11. All right, now 600 divided by 11. Simplification is not a problem. Dividing by 11 is not a problem. You can do this. 11 5 times 55, 11 4 times 11 4 times 44. Therefore 6 divided by 11. That is the speed. This is the speed in kilometers per hour. All right, so this is the speed in kilometers per hour. Anyway, nevertheless, my point is what? My point here is, okay, speed and time are inversely proportional when the distance is constant. And average speed is nothing but weighted average of speeds. If you understand this much, job is over. Weighted average of the speeds. So what are the weights here? Weights are nothing but time. If you get this point, fairly done. You're fairly done. You understood about the average speed. You fairly understood about the average speed. One last example, then we'll go to the third point of discussion. Which is the relative speed. One last example. Take a minute, friends. Take a minute. Worth taking a minute and trying to solve it. Take a minute. Put it to perspective. Find the average speed. Okay, I thought all right now. So I think all right now you got this. Fine, let's take a look. Nevertheless, a man travels 1/5 of the distance. 1/5 is what? Already can I convert into percentage? Yeah, distances are fine. So he's saying something like this. Okay, if I put a line diagram, he's saying that 20% of the total distance, 20% of D. Assume that D is the total distance. 1/5. What is the 20%? Good. Then he said that all right now next is what? Half of the distance. What is half? 50%. Might look something like this. This is half of the total distance. 50%. All right, 50%. That is nothing but half of the total distance. Half of the total distance, right? Half of the total distance there, 50% of D. Yeah, what about the third point? The third point is therefore the remaining distance. He used the word remaining. What is remaining therefore? The remaining is 30% of the distance. Is that fine? Yeah, that is fine. 30% of the distance. What I'm trying to do here. Because see, what is that ultimate, what is that I want in the absolute terms? Absolute terms is the speed. Speed I want in the absolute merit. And what else I want? I want the time in the form of a ratio. Period. That's it. This is all I need to understand. All I need to understand is speed should be in the absolute terms. Otherwise, I will not be able to find the average speed in absolute terms. Second is what? I want the time ratio because already now time are the weights. Weights can be in the form of a ratio. Therefore, when you talk distance, etc., it is all to give you the value of the time. All right, in the sense the ratio of the time. All right, now they are trying to help you to find this. Therefore, what you want to write in fraction or percentage or decimal does not matter to me because we are leading towards time ratio. That's it. All these are leading us towards time ratio. That's all I need to understand. Speed has to be in the absolute terms. Speeds are already in the absolute terms. There is no problem with that. Hey, what is the speed of the first leg of the journey? That is given to me. Speed of the first leg is 50 kilometers per hour. Hey, 40 kilometers per hour. Second leg of the journey, 50 kilometers per hour. Second leg of the journey is 50 kilometers per hour. The third leg of the journey is 12 kilometers per hour. That's given. So therefore, he's asking me the average speed. I just need the times now. Hey, what is the time for the first leg of the journey? Ratio of the time for the second. Ratio, not absolute times. These times, I just want the ratio of these times. That's all I need here. Perfect. All right, therefore, it's perfect. Yeah, how do I find the T1? T1 is equal to D. What is time here? Time is nothing but the distance by speed. What is time, friends? Basically, time is nothing but distance by speed. Good, I will find it. Yeah, therefore, T1 is to T2 is to T3. You are trying to find out T1 is to T2 is to T3. Perfect. All right, now, so what is all it? Therefore, what distance by speed? Write it. Distance by speed. 20% by 40. you're writing it as 20% of d, or 20% of d by 40. You're trying to write 20% of d by 40, that is the t1. Hey, what is t2? T2 is 50% of d, or 50% of d by 50. Very good. Hey, what is t3? Or t3 is what is t3? T3 is 30% of d divided by 12. All right, this is what you are trying to tell me. Fair enough. All right, no worries. So now what? All right, no percentage, and anyway it's a ratio what you are writing. So you wrote a lot of redundant information. Nevertheless, all right, now while I'm teaching as a teacher, I don't have a choice but to write and express things like that. If you are writing, you don't write all this drama, this diagram, etc., etc. I am taking time to illustrate. When you solve, it's a 1 minute problem, right? Okay, percentage d, percentage d, percentage d, cancel. All right, all these are cancelled. Technically, you are saying that all right, man, this is 1:2, this is 1 by 1. All right, and this is 5 by 2. Multiply throughout by 2 because LCM of the denominator. Therefore, multiply throughout by 2, you get 1:2:5. That is the ratio of the times taken. 1:2:5. This is 1, this is 2, and this is 5. That's a ratio. That's enough for me because it's a weight. Weights can be in any form. That's a ratio. Therefore, what you will say that 40 into 1, 40. You are writing average speed. What you are writing average speed, that is 40 plus 50 into 2, 100. 50 into 2, 100. 12 into 5, 60. Divided by what? The weights, that is 1 plus 2 plus 5. Divided by what? 1 plus 2 plus 5. Right now, therefore, you are trying to say that this is nothing but 200 divided by 8, all right, which is again simplification, 25 kilometers per hour. That's the average speed. Average speed for the entire journey finally turned out to be 25 kilometers per hour. That's a simple question, pretty simple question. I guess all of you understood this. All of you understood this. How these weights of time are going to help me big time, all right, in critical problems. That's very, very important. Okay, I kind of talked about 2 or 3 things about this average speed. I hope all right you sufficiently recalled from your schools, whichever method you did. Schools generally do the equation methods. They do a lot of equations there. Even they don't use when the distance is constant, speed and time are inversely proportional. They don't use that. Instead, they tend to write the equations. I thoroughly avoid it from the beginning because that is nothing to do with us in CAT. We don't keep writing the equations unless it's a really, really big time mess. All right, yeah. So that we will see it at a later stage. Generally, they are not so very messy. You just have to understand what is a smart way to deal with this. When the distance is constant, speed and time are inversely proportional. When the time is constant, speed and distance are directly proportional. That is going to help us big time rather than trying to write the equations, etc. That's a point I'm trying to illustrate here. Because we are now so good at weighted average, what helps us is, hey, average speed is nothing but weighted average of speeds will help us because we already studied weighted average. Then why don't we capitalize on that? Why should I go back to the way I used to do it in the schools? Not necessary, isn't it? Yeah, okay, fine. Let's go further. Let's now go to the relative speed. Let's now go to the relative speed. I hope all of you kind of understand what is the relative speed, because of if you travel, as you travel, you know that overtaking happens, crossing each other happens. All these are the issues of the relative speed, right? Therefore, it should not be much of a concern for you to understand what is the relative speed, etc. Nevertheless, let me give a small background as to for us from the problem solving perspective. What about this? Now, what are the important parameters? Let me illustrate this. See, for example, so things may be moving in the opposite direction or the same direction. Two cases under relative speed, isn't it? Relative speed is two cases. Case one, let me just illustrate. I know that all of you are comfortable, you are aware. If I ask a question, you will immediately answer. That's not a worry. But nevertheless, without taking things for granted, let me explain it for you. Okay, so now say that, okay, A is traveling in this direction. There is a person B who is traveling in this direction. Car A is traveling in one direction. Car B is traveling in another direction. Let's say the speed of car A is S1. The speed of car B is S2. Let's assume speed of car A is S1 and the speed of car B is S2. The distance between them is D. The distance between them is D, and they start simultaneously at the same time. It's a race. It's a race or whatever. You blow the whistle, both of them would start. Assume you're watching something on the screen. You're playing a game. The distance you maintained is D. A is traveling with the speed of S1. B is traveling with the speed of S2. They're coming together. Now, important point here is what is that I want to understand here. All right, no, so what I want to understand is that when do they meet? All right, time of meeting. When do they meet? All right, you have stopped. You have started that. Okay, move. All right, you've blown the whistle. Both of them started, and then you are put the time watched. All right, or timer you have switched on, and then where they are going to meet. Assume that this point is X, this point is Y. They are going to meet somewhere at Z. They are going to meet somewhere at Z. A would have covered this distance. The car A would have covered distance because it's having a higher speed. It will cover a little more than half. Right? Car B would have covered this particular distance. Car B would have covered this particular distance in the given time. All right, now that out of the total distance, this is what they would have covered. So how do you write the time of meet? All right, if they're traveling in the opposite direction. What is that we are talking about? The first case, friends, opposite direction. All right, opposite direction. When they're traveling in the opposite direction, the time taken to meet. First of all, what is time? Time is nothing but distance divided by speed. Time is nothing but distance divided by speed. All right, distance divided by speed. But the time, I can also write it as total distance. Collectively, total distance. If you write total distance, add the same adjective, write it as the total speed available. All right, if the total distance has to be covered, then what is the total speed available? Because now you're adding an adjective. Time is equal to distance by speed, that we know. But you added an adjective, total distance. Then add the same adjective. Don't change that adjective. All right, adjective should be same. You wrote total and now don't write average speed. All right, if you're writing total distance, you better write total speed. Don't try to write average speed or don't write extra speed. Don't try to change the adjective there. Maintain the same adjective. Why? Because both of them together are covering the total distance. Why? The first car 1 is covering d1 distance, car 2 is covering d2 distance, but together they are covering the d distance because d has been divided into two parts, d1 and d2, but together they covered what? To both the distance d1 and d2. That's what you are writing, total distance traveled. Then you better write what is the total speed available. Total means sum, we all know that word. All right, total means sum. Therefore we write it as s1 plus s2. Now this is called as relative speed. This s1 plus s2 is called as relative speed. If the things are moving in the opposite direction, if the two vehicles are moving in the opposite direction, relative speed SR, I will write it as SR. The relative speed is nothing but the addition of the speeds. Why? Because we use the adjective total. We use the adjective total. Total distance covered by them. One vehicle is covering d1 distance, other vehicle is covering d2 distance. We shift our attention to total. Total distance traveled. Then you better write the total speed available. Don't write average speed available. Alright, you will write the total speed available. That's what you wrote. What is the total speed available? S1 plus S2. You remember from the schools, therefore this relative speed when the things are moving in the opposite direction is nothing but S1 plus S2. That's a very basic understanding I tried to give you. Very basic understanding I gave. So I will get into the depth of this. There are a few more points. As I was teaching you the average speed, how I give some points, I will give some points when I get onto the examples. But this is a very basic understanding that you should be aware of. Pretty basic understanding you should be aware. Let me take the second case here. Let me take the second case. What is the second case? When both the vehicles are moving in the same direction. Assume that there is a head start given. Assume that there is a head start given for B, head start given for B. Assume that the B stays here, B lives here. Assume that B lives here and he is moving towards his college or office. A lives here. Both of them start at the same time. Both of them come out of their houses at 8 a.m. or whatever the time there. Or let both of them move in the same direction, let's say. And both of them have to reach Y. Both of them so they start from different points. He starts from point X, his house address is Y, B's house address is Y, and they meet at a point Z. That is the office. Let's say that Z is the office. The point is, somehow they are meeting there, they reach the office exactly bang on at the same time. They reach exactly at the same time. Both leave home at the same time, both reach office at the same time, which means what? Definitely the speeds are different. This fellow has a speed of S1, this fellow has a speed of S2, and I know that S1 is better than S2. Absolutely no doubt, S1 has to be better than S2 because both are reaching Z. Z is nothing but the office at the same time. Yeah, how both of them reach the same time if both of them leave home at the same time? Naturally, S1 has the better speed. All right, because they leave same time and they reach office at the same time. So therefore, S1 is better than S2. I hope all of you got this point. Now look at this. Hey, what is the distance? Let me call this particular distance as X. Let me call this particular distance as D1. Let me call this particular distance as D1. Let me call D. Let me call it as D. Let me call this distance as D. And let me call this particular distance as A. A is already used, right? Okay. Let me call this particular distance as P. Let me call this particular distance as P. In the given time, what is constant here, friends? Time is constant, right? Time is constant. Both of them traveled for the same time because both left their homes at the same time and they both reached the office at the same time. What is constant? Therefore, is speed constant? No. Is the distance constant? No. What is constant? Time is constant. See, even if I don't tell it deliberately every time for the question, you can always think about it. One of them will be constant in the given question. Either time is constant, speed is constant, or distance is constant. Either for the full journey or the part of the journey. That is given, guys. That is given in the time, speed, distance question. If you miss that particular point, then you will start wondering what is this question about. That's the first thing that I want you to note or understand every time. Okay, here we go. So now, therefore, what is in the given time? In the given time, what is the distance traveled by A? Or what is the distance traveled by A? Think about it. What is the distance, total distance traveled by A? D has traveled the distance traveled by A. I'm talking about. Yeah, what is the distance traveled by A? Distance traveled by A is D plus P. He traveled this distance D. Alright, A has traveled this particular distance D. Also, he traveled this particular distance called P. He traveled both these D plus P to reach the office in the same time. Time is constant, isn't it? In the same time. In the same time, what is the distance traveled by B? What is the distance traveled by B? Only this. He has traveled only a distance of P. Only a distance of P. Okay, now he has traveled only a distance of P. Therefore, what is the extra distance traveled? Extra distance who? Extra distance traveled by A. Extra distance traveled by A is D. Extra means what? Subtract. Extra means what? Subtract. You are subtracting this. Therefore, what is the extra distance traveled? D. Therefore, extra time available. So that's what we said here. Time is equal to distance by speed. Correct. Okay. The same time can be written as extra distance traveled. Extra distance traveled by extra speed available. Extra speed available. A very same. Use the same adjective. That's all my point is. If you write extra, you better write extra. Don't write average speed. Extra distance, then you better write the extra speed. Right? Don't try to write something else there. Okay. Use the same adjective. That's a point there. Extra distance. Say, what is the extra distance, friends? D. Therefore, what is the extra speed? S1 minus S2. Therefore, what is that extra speed? That's what happens in the same direction. When they are moving in the same direction, when they are moving in the same direction, it's a concept of extra speed there, right? It's a concept of extra speed called as relative speed, because both the terms we call it as relative speed, but it's an extra speed. All right, relative speed in this case is nothing but S1 minus S2. Because what is the relative distance? It's nothing but d. So therefore you are saying that, hey, this can be written as time of meet. That is when they meet together. Time of meet is d divided by, all right, the relative distance, relative speed between them, s1 minus s2. That's the point. All right, now so I hope the point is, all right, now this same the same direction, it is going to be s1 minus s2. All right, opposite direction, it is going to be s1 plus s2. Opposite direction, it is going to be s1 plus s2. I just illustrated the same points, all right, using the same adjectives. Keep the same adjectives. I hope I sufficiently helped you to recall that particular discussion. Sufficiently helped you to recall. Here we go with the question. Here we go with the question. Let me do this question for you. All right, because I will tell little more there. All right, it's not end of it. So that's very basic. You understood that. One more thing I will tell after this question. Then you are comfortable. Relative speed should be crystal clear to you. Let's do this particular question, because I will add another 2-3 points with this question. Here we go. P travels from X to Y, which is at a distance of 60 kilometers at 11 kilometers per hour. That's the speed, starting at 12 in the afternoon. Q leaves Y to X. There is another fellow. He started from the other side. Idea is to meet his friend P, but he's left at 2 p.m. and reached at 8 started with a speed of 8 kilometers per hour. Maybe they are cycling or whatever is that. Okay. At what time do they meet? I want the time on the clock when they met. They looked at the time. What is the time there? And they're checking what is the time at which they met. Sure. All right, now 3 things, friends. Remember that. All right, now remember 3 things are important. Number 1. All right, number 1. All right, point number 1. All right, that's a very important thing. At what time? At what time the relative speed comes in the picture? All right, relative speed only. Correct. At what time relative speed comes in the picture? See, relative speed means more than one object should be moving. Otherwise, there is no question of relativity, right? No, relativity means there should be more than one moving. If only one vehicle is moving, the other one is stationary, there is no question of relative speed. Relative speed means more than one should be moving, but we will take 2 at a time. That's easy to analyze. We'll of course take 2 at a time, but then more than one should be moving, which means minimum 2 should be moving. That's the point we are trying today. Therefore, first point you should ask is, at what time the relative speed comes in the picture? Simple, it comes in the picture at 2 p.m. All right, that's the first thing I want you to notice. 2 p.m. it comes in the picture. Why? The first vehicle started at 12 noon. The first vehicle started at 12 noon. But the point is, the second vehicle started only at 2, which means 12 to 2, only one vehicle was moving. Therefore, at what time the relative speed is coming in the picture? At 2. See, these are the deliberate thoughts in your mind. I'm not saying that while writing in the exam, you should write all of this. No, you can't miss those points in your mind. That's my point. You can't already, you can't be already, you can't, you should be conscious of thinking about them. That's a point here. Good relative speed. What time the relative speed came in the picture? Point number 1. Point number 2. What is the distance to be covered under the relative speed? What is the relative distance? Hey, what is the relative distance? In other words, what is the distance to be covered under the relative speed? That's a point. All right, now that's a point I'm trying to tell you. So, which means, am I conscious about them? If you get these elements right, getting the answer is no problem there. You easily get the answer. All right, now you will easily get the answer. No issues about that. But my points of thinking has to be clear. I should not miss out on the points there, and I should not make a mess out of it, because there is no clarity in thinking. Don't make a mess out of it. It becomes a mess. If there is no clarity, it becomes a mess, right? Yeah. First point of thinking: at what time relative speed comes in the picture? What is the relative distance? Therefore, what is the relative speed? All right. Therefore, point number 3. Okay. Therefore, what is the relative speed? Therefore, what is the relative speed? If you think about these 3 things clearly, then you are done. If therefore, what is the relative speed means what? Opposite direction or same direction? Opposite direction, add the speed. Same direction, subtract the speeds. That's a point there. Okay, good. Let's illustrate this. All right, now these are the 3 points. Done. Basics are over with this. That's it. If you are able to think about these 3, and we already had a discussion previously, put them together, your relative speed is actually covered. I'll just do 3-4 examples before I go for the deeper sets. All right, before I go for other kind of questions. Sure. Let's take a look here. Let's take a look here. What is happening here? So one fellow started from, one fellow P started from X. The other fellow started from Y. Well, P started here. What time did P start? P started at 12 noon. P started at 12 p.m. Well, P started at 12 p.m. What is the speed he maintained? 11 kmph. 11 kmph. That's 11 kilometers per hour. Yeah, what is the distance between them? 60 kilometers in all. Totally it is 60 kilometers. Okay. So what time the queue is starting from here? The queue is starting from here at 2 p.m. All right, at 2 p.m. So what is the speed that he's, or what is the speed at which he is starting? He is maintaining a speed of 8 kilometers per hour. Like 8 kilometers per hour. Very good. All right, let's see that. Okay, what time the relative speed comes in the picture? At 2 p.m. right? At 2 p.m., not before that. Therefore, till 2 p.m. only one fellow is moving. 12 to 2, let's assume that the p will be at z. P would reach the point called z. What is the time at that point in time? 2 p.m. Therefore, what is the distance covered by him? The distance covered by p. The distance covered by p in 2 hours is nothing but 2 hours time into speed. What is the speed, friends? 11. 11 into 2, 22 kilometers. You would have covered 22 kilometers. Okay. Out of 60, 22 kilometers is covered. What is the remaining distance? Therefore, z to y. Z to y. Therefore, the remaining distance is nothing but another 38 kilometers. That's a point here. Relative speed comes in the picture at 2 p.m. What is the relative distance? Relative distance is 38 kilometers. These are the 2 points I should be ready with. 2 p.m. the relative speed is coming in the picture, and the distance to be covered under the relative speed is 38 kilometers. Are they moving in the opposite direction? Yes. If they are moving in the opposite direction, the relative speed will be the sum of the speeds. What is the sum of the speeds here? 11 plus 8. 11 plus 8, which is nothing but 19 kilometers per hour. All my ingredients are ready. Therefore, the time of meet starting at 2 p.m. Time of meet. Time of meet starting at what time? 2 p.m. Now I am writing this relativity at 2 p.m. Entire relationship at 2 p.m. Time of meet. Total distance to be covered, or a total distance to be covered at that point in time, 38 kilometers. You are saying that, okay, these fellows have to cover 38 kilometers. Good. He has to cover 38 kilometers. 38 kilometers. What is the relative speed, friend? 19 kilometers per hour. 19 kmph. Alright, therefore, what is the hours required there? 2 hours. 2 hours from where? From 2 p.m. 2 hours from 2 p.m. is nothing but 4 p.m. You are trying to say that, look, these fellows are going to meet at 4 p.m. 4 p.m. they are going to meet each other at some point between Z and Y. At some point between Z and Y, I'll let know somewhere here, I'll let know between Z and Y, they are going to meet. Call this point as R. Somewhere there they are going to meet that. Okay, that's about this particular question. Okay, so by now the entire element should be clear. What is that? Be clear in your mind, thinking at what time the relative speed, relative time comes in the picture, what time the relative distance comes in the picture, or in the sense at what time the relative speed comes in the picture. The time should be clear, the distance to be covered should be clear, and what is the relative speed, that should be clear. If you are clear about thinking about these three things, more or less problems are fairly done. Okay, let's go to the next one. Let's go to the next one. Let's go to this particular question. Let's think about this. A hare sees a dog 100 meters away from it, right, which means it spots the dog, and then it runs off. Right, it runs off in opposite direction at a speed of it does not run towards the dog. It does not run towards the dog. It is going in the opposite direction. The moment it sees it, right, it is on its feet. It's running. Right, yeah, 18 kilometers per hour. A minute later, the dog sees it and gives it a chase. And gives a chase at a speed of 24 kilometers per hour. How soon will the dog overtake? How soon will the dog overtake this particular hare? All right, that's a question there. All right, let's take a look. How do we go about this? So something like this, something like this. Let's say that, okay, so initially when it sees it, the hare is here, let's say. Let me draw a line diagram. Every time in the exam, line diagram, etc. are not important, friends. To explain, I draw. If you're doing it on your own, please don't do unnecessary drawings. It's a waste of time. All right, don't do unnecessary drawings. While learning, you do. But after learning, please have the diagram in your mind, unless it's a very complex case in itself. Right now, most of the cases are not complex. Rarely they are going to be complex. Don't get into the habit of drawing the things, etc., etc. every time. Not required. For explanation, I have to draw. Otherwise, if I keep in my mind and I start talking to you, you will not understand where is that point XYZ, what you are talking there. All right, that becomes an issue. Therefore, I have to draw. But all right, don't think that I have to draw. You also have to draw every time. Absolutely not. All right, you got to perceive it in your mind to generate the speed, not drawing. Drawing also takes unnecessarily more time, right? Yeah. So develop that speed. All right, develop that speed. Sure, draw when the things are very complex. When the issues are very complex, please go ahead and draw. Right? Otherwise, don't. All right, for simple issues, don't draw. Okay, let's go here. All right, let's go here. So it leaks 100 meters before hare is here. Let's assume that the hare is here. Dog is spotted here. Say what was the distance there? 100 meters. And then it took run. It started running. And then after 1 minute, the hare was here. After 1 minute, all right, this is the first position of hare, position 1 of the hare. This is the position 2. That is when dog sees it. That is when dog sees it and gives a chase. All right, that is when dog sees it and it gives a chase. Hey, what is the speed of the dog? 24 kilometers per hour. 24 kmph. Yeah, what is the speed of the hair? What is the speed of the hair? Hair was here initial position, that's the second position. Wherever it is, the speed of the hair, the speed of the hair is nothing but 18 kilometers per hour. It doesn't matter, both the places. It is 18 kilometers per hour. Where do they meet? They meet somewhere here. They meet somewhere here, which means hair and meat are together. Hair and dog are together. Where? Somewhere here at the point called something like P. At the point, point called P, they will be together. See, but the point here is, okay, but the point here is, what is the extra distance to be covered by the dog? This is the extra distance because when the dog observed the hair was already at P2. The hair was already at P2. Therefore, that is the extra distance to be covered. What about the remaining distance? That has to be covered by both of them. What point in time it comes in the picture? From the point in time it comes in the picture, this is the extra distance to be covered by the dog to catch up with the hair, because the remaining distance is constant. What about this particular distance where I'm putting this circle? That is anyway covered by both hair and dog in the same time. All right, now, so whenever the relative speed comes in the picture, let's take a look at this, guys. All right, 1 minute, what is the distance covered by hair? All right, let's write the answer. Answer should be in terms of what? Minutes. Okay, no worries. Let's first write it. All right, in 1 minute, what is the distance covered? What is the distance that is going to cover by hair? I need this distance because I'm ready with this distance, which is 100. Second distance is what I want. Good. The speed I know. Speed is what? 18 kilometers per hour. The speed of hair, I'm writing speed of hair, guys. Speed of hair, 18 kilometers per hour. 18 kilometers per hour. Let me convert it to meters per second. If I convert it to meters per second, it will become 5 by 18 meters per second. Therefore, 5 meters per second. That is the speed. Okay. Therefore, the distance covered by the hair, in 1 minute. 1 minute means 60 seconds. Therefore, 5 into 60. Distance is in terms of meters now. Speed into time. What I did, what is this? 5 meters per second. That is the speed. Yeah, what is that? 60 seconds. Because 1 minute, author said that it is 1 minute. All right, no, 1 minute later. 1 minute later. 1 minute is nothing but 60 seconds. So 60. All right, therefore 5 into 60, 300 meters. All right, you are talking about 300 meters. All right, 300 meters. Good. So therefore this distance is 300 meters. Yeah, what is the total gap between them? Therefore, what is the relative distance? All right, number 1 point. What time relative speed came in the picture? Sometime t, sometime called t. Now the relative distance came, and now relative speed, because it's not a time issue. What time on the clock they are meeting? It is not what time on the clock. Whenever the relative speed came in the picture, what is the distance to be converted under the relative speed? Distance is 100 plus 300, total 400 meters. The distance to be covered is 400 meters. Very good. Hey, what is the relative speed, friends? What is the relative speed? What is the relative speed? Both are moving in the same direction. If both are moving in the same direction, it's a difference between the speeds. That is 24 and 18. What is 24 and 18? 6 kilometers per hour. But this is in meters. Converted 6 kilometers per hour. Let me convert it to meters per second. 5 by 18 meters per second. Therefore, you would say that this is nothing but 5 by 3 meters per second. Good. I get the time now. Therefore, what is the time of meet? Therefore, what is the time of meet? Distance by speed. Do I know the distance? Yes. Do I know the time? Yes. All right. Therefore, you would say that 400 divided by 5 by 3 meters per second. Okay, 5 by 3 meters per second. Good. Okay, thereby what do I get here? All right, thereby what do I get here? All right, so you get it as 80. All right, 80 into 3, that is 240 seconds. All right, 240 seconds. But author said that I want answer in minutes. Good. If you want in minutes, then time in minutes. Time in minutes is 240 seconds divided by 60. You will say that, okay, they are going to meet after 4 minutes. They are going to meet after 4 minutes. Whenever the dog noticed it, it takes 4 minutes from that instance to catch up with the, how soon will the dog overtake it. Dog will take 4 minutes to overtake this particular hair. All right, overtake this particular hair. Pretty simple one. I hope all of you got this. I did two examples. One was moving in the opposite direction, one moving in the same direction, other one is moving in the same direction. I hope all of you got both the perspectives here. I said that, okay, conversions from meters per second to meters per second to kilometers per hour, etc., has to be very seamless. All right, that should go seamlessly well. That's very important there. Okay, second thing is, be mindful about what time the relative speed is coming in the picture. What is the distance to be covered under the relative speed, and what is the relative speed? Be mindful about asking these questions to yourself, so that already you will get the elements right. I hope all of you got this point here. All of you got this. Let's take up one more question. Beautiful one. Beautiful question. Take a minute, put all the understanding that I have given so far to you. Put all that understanding and solve this question, friends. Yeah, I'm sure all of you might have solved it. I'm sure all of you might have solved it. I'm sure because I give sufficient input. I'm sure all of you might have done solved it. See, in addition to whatever I said so far, so another important thing here is the distance is constant, isn't it? In addition to whatever I said so far in this question, again, the distance is constant. That's another additional point here. Additional point is the distance is constant as well. In whatever I'm saying so far, in addition to that, the distance is also constant. Why? Because anyway, I already know the train P is moving between point X and Y. Train Q is also moving between y and x and y, or y and x, whichever the side that you move from. So therefore the distance remains same. If the distance is constant, then the speed and time are inversely proportional. Let's assume that, okay, the p, what is the time taken by p? 6 o'clock it starts and it reaches the destination at 3 o'clock. 6 to 3, how many hours, friends? 9 hours. Therefore train P takes 9 hours. Hey, what about the train Y? What about the train Q? Train Q starts at 8 a.m. and reaches at 2 p.m. 8 a.m. to 2 p.m. At 8 a.m. on the day and reaches at 2 p.m. there. Alright, therefore, how many hours it is taking? This fellow is taking 4, or this fellow is taking 8 hours. 6 hours. This fellow is taking 6 hours. One train is taking 9 hours to do the journey. Other train is taking 6 hours to do the journey. See, what time they start, what time they reach is a different issue. But do I know the total time of journey by each train? That I know for sure, isn't it? That I know for sure. So therefore, how do you write? If the distance is constant, the speed and time are inversely proportional. Of course, we'll write that there is a speed, there is a time. All right, now there is a train P and there is a train Q. Yeah, what is the time take? All right, time and speed are inversely proportional. Yeah, what is the time taken by train P? Well, 9 hours. 9 hours. It started at 6 a.m. That's a later issue. We'll come to that issue later. But how much time it is taking? 9 hours. Yeah, what is the time taken by Q? 6 hours. Q is taking 6 hours. This is clear to us. Therefore, what about the speeds? Speeds will be in the inverse ratio. Speeds will be in the inverse ratio. Therefore, what is the speed here? Speeds will be in the ratio of 2x and 3x. Why? Because the time ratio is 9 by 6. Therefore, speed ratio is what? Inverse ratio 2 by 3. Or inverse of that 2 by 3. So therefore, hey, I can ignore this x also because it's anyway dummy problem. What is that I want? What time do they meet? Or at what time do they meet? I can ignore this x, not required, because I'm not finding the total distance, which anyway I cannot find, but the relationship I can find. Therefore the distance, all right, therefore the distance 9 into 2, 18 kilometers. I'll take it as 18. 9 into 2, 6 into 3, that's also 18, because anyway both are traveling the same distance. That will not change. Nevertheless, that won't change there. Okay, therefore 18 and 18, distance is 18. So now you can take that, understand this. Okay, there are 2 points x and y. There are 2 points x and y. The distance between them is 18 kilometers. P started here. P started here at what time? 6 a.m. P started here at what time? P started there at 6 a.m. P started at 6 a.m. Alright. Q started at what time? Q started at 8 a.m. Q started at 8 a.m. Therefore, at what time the relative speed is coming in the picture? At what time? At what time the relative speed is coming in the picture? At 8 a.m., not at 6 a.m. Because from 6 a.m. to 8 a.m. only one vehicle is moving. Therefore, the relative speed is coming in the picture at 8 a.m. only. Perfect. All right, now that's coming in the picture at 8 a.m. That's one. Hey, what is the relative distance? Distance to be covered under relative speed. That I need to find out. Why 6 a.m. to 8 a.m.? What is the speed of the P, friends? What is the speed of P? Speed of P is 2 kilometers per hour. Therefore, all right, now 2 from 6 o'clock to 8 o'clock, P will reach you. 6 o'clock to 8 o'clock. All right, now this is 8 a.m. Assume that by the time the train P reaches a point called Z, it is already 8 a.m. It's 8 a.m. So what is the distance already it covered between 6 and 8? All right, that's knowledge. It covers, what is the speed here? 2 kilometers per hour. In for 2 hours, this is 2 hours. 2 hours is the journey. Therefore, what is 2 into 2? 4 kilometers. All right, if this is 4 kilometers, what is the remaining distance? 14 kilometers. The remaining distance is 14 kilometers, because the total was 18 kilometers. Therefore, this remaining z and y is 14 kilometers. That's a relative distance. What is relative distance? 14 kilometers. Relative speed is coming in the picture at 8 o'clock. Relative distance to be covered is 14. What is the relative speed itself? What is the relative speed itself? Sum of the speeds, that is 3 plus 2. Therefore, that is going to be 3 plus 2, which is going to be 5 kilometers per hour. All right, that is 5 kilometers per hour. Okay, therefore, what is the time of meet? All right, therefore, what is the time of meet? Time of meet, therefore, is nothing but the relative distance to be covered, that is 14 kilometers. The relative speed is 3 plus 2, which is 5. All right, relative speed is, which is nothing but 5. That is 14 divided by 5. That is the time of meet. Well, what is 14 divided by 5? 2 full hours. 2 full hours, another 4 by 5 hours, 2 4 by 5 hours. What is 4 by 5 hours? 4 by 5 hours is 48 minutes. 4 by 5 hours is 48 minutes, which means it takes 2 hours and 48 minutes. How to convert 4 by 5? 4 by 5 into 60, if you do, you will get 48 minutes, isn't it? Yeah. So therefore, only 2 hours 48 minutes. What time the relative speed came in the picture? 8 o'clock. Therefore, your answer is after 8 o'clock, at 8 a.m., right? Relative speed came in the picture at 8 a.m. It takes 2 hours 48 minutes from there. Therefore, what is the time? At what time? The question is at what time? Time now is 10, or at 10 o'clock, 48 minutes. 10:48. All right, the time now is 10 o'clock, 48 minutes. Why? Relative speed came in the picture at 8, and we want another 2 hours, 48 minutes. Simple question, simple question. Be mindful. So sometimes there will be some distance constant. Some things author would be giving some additional information. Be mindful about that information. Then the question becomes a lot more easier to solve. All right, lot more easier to solve. I hope everybody is getting a perspective here. I hope everybody is getting a perspective here. Right, I guess you are enjoying, you are getting the point what I'm trying to say. Right, you are getting the point what I'm trying to say. Good. All right, now there is a concept of this extra time, delta time. We call this as the concept of delta. All right, there is there is a concept of delta time. All right, delta time, extra time. We call it as a delta time. All right, delta time. Okay, so let me just illustrate this. What is this delta time, extra time? So what happens here is, okay, even don't read that question, don't bother. First understand this. There are two vehicles. There are two vehicles. Say, all right, now there is a vehicle A which moves from here, vehicle B which is moving from here. Right now, so let us assume that, okay, so vehicle A starts from the point X, vehicle B starts from the point Y. They meet, they both start simultaneously. First point will be, are they starting at the same time? Yes, they start simultaneously, which means they start at the same time, and they meet. They meet at a particular point. Let's assume that, okay, they met at this particular point. They met at a point called M. So far, they will not tell us anything. They started simultaneously. Both A and B were here. A was here at the same time, B was here. Both A and B were here at this time. Now they will say that after meeting, all right, delta A, time taken by A. Now they will say that, all right, now TA means what? Time taken by A. After what? After meeting, friends, after meeting. Let me call it as delta TA. Time taken by A, all right, now is going to be, let us say, delta, now time taken by A is going to be TA, let us say. Delta of time, extra time. All right, let me call it as delta TA. Time taken by B to complete the journey after meeting is going to be delta TB. All right, delta TB. That they will tell that. Now they will ask a question that, hey, how much time did they take to meet? That's a point they will ask. Both started simultaneously, right? So how much time did they take to meet? What they have given the extra time required after meeting. Extra time required by A and B after meeting. In this case, the time of meet, which means time taken when they left simultaneously, time taken by them to meet is nothing but under root of delta TA into delta TB. This is going to be delta TA into delta TB. That is what it is going to be. Okay, let me put this portion to perspective. You might have vaguely understood this. Guys, please remember this directly. Proof is really, really simple. It again comes from the relativity of the speeds itself, or it comes from there only. But please remember this directly, because otherwise I will simply keep proving it. It's of no use after that. There is nothing of much use there. This is the only kind of questions which are built around this particular concept. Please remember this directly, and we are done for the day. Alright, then we are done with this particular concept. Let's not get into the proofs, etc., etc. Alright, let's not get there. Alright, if you really want the proof, please open your 8th standard book. It is there. Alright, it is there in your 8th standard book. Alright, 8th or 9th, based on the boards that you study. Some boards 8th standard, some boards 9th standard. You find a beautiful proof for this, and it's really, really elementary and simple. Don't bother about this. If you remember this, you are done for it. Okay, proof all that is a high school issue. Pythagorean theorem can be proved in 7 different ways or 8 different ways. All of you would have done this project in the school. Right now, prove that Pythagorean triplet or Pythagorean theorem. Right, you write like this. Alright, you will prove this. Right now, this is A, this is B, alright, this is C. Therefore, we all say that C square is equal to A square plus B square. Task given to the kids is what? Prove it in 3 ways. Prove it in 4 ways. That's what they will ask in the high school. Now, today you might not remember even one way of doing with this also. That's a different issue. Don't bother. Alright, no, of course you will remember. I'm just kidding. I'm kidding. My point is, alright, now some of you already now sitting and listening to this lecture might have proved it in 6-7 different ways as well. That's also true. That's also true. How many of them you remember? That's a different issue. But that's a school issue. School is always interested in proofs. We are interested in application. application. We are interested in application. Right now, school is always interested in proofs. Proofs always carry more marks because that's an elementary education. Now, application is what we were learning here. Therefore, I generally don't spend too much time on the proofs, etc. Because that's never going to be asked. Hey, prove that outlet how Pythagorean theorems comes like this. Not required. Not required. Even if you don't know, you'll be successful in entrance exams where you don't have to really necessarily know that. That's only intellectual curiosity. All right, now it may not be really result oriented study. Okay, fine. Let's go in here. Let's go in here. Let's not bother. Let's remember this point. Okay, let's come back to this point here. So what is this weather? What is the scenario given here, friends? Same scenario. What is the scenario given here? There is one vehicle starting from Bangalore. There is one vehicle starting from Chennai. One vehicle starting from Chennai. A is starting from Bangalore, same time. B started from Chennai. Time is same. That's very important. Same time. All right, now they started towards each other at what time, friends? 6 a.m. Both of them started at 6 a.m. Both of them started at 6 a.m. After passing each other means okay, they met at a point called M. They met. They met. A came here. All right, A was here. B was here. At the same time, B was here. Both were there. Okay, after passing each other, all right, after passing each other, they take 4 hours and 9 hours to reach Chennai and Bangalore respectively. What is that they are trying to say? After passing, A takes 4 hours. Hey, the 4 hours is not the total time of the journey, guys. After crossing, A requires 4 more hours to complete the rest of the journey. Whereas B requires 9 hours to complete this particular journey. What is this 9 hours? Extra time required after meeting. So to meet, they've already taken T hours, which means, look, what is the total time taken by A? Total time taken by A is T plus 4 hours. All right, it will be T plus 4 hours. Say, what is the T? All right, T is nothing but the time taken to meet. All right, T time is taken by A to reach the point M. Bangalore to point M. A has already taken T hours, and it is going to take another 4 hours to reach from M to Chennai. All right, point M to Chennai. Okay, what is the total time taken by B? Total time taken by B is nothing but T plus. What is the T? Time taken by vehicle B to reach from Chennai to M. Chennai to point M. All right, now that is T hours. But from M to Bangalore, how much time it is taking? Another 9 hours. That's a total time. But the point here is, okay, because both have left at the same time and went here, the time of meet, that is the T. All right, the T I'm trying to find out. This T, guys, this T is what I'm trying to find. Hey, what is this time T? This time T is nothing but delta time. That what is this delta? This is what I'm calling it as delta. This is delta TA. This is delta TA4. Yeah, what is this? This is delta TB. What is this delta? Delta means that extra time required after meeting. That is delta time B. So that is, these are the numbers I should be writing here. 4 and 9, 36. All right, 4 and 9, 36. Therefore, T is equal to 6. 6 hours they traveled together. 6 hours they traveled. They met after 6 hours and then they crossed each other and then went to their destinations. They took those extra times to reach the destination. But the question here is what? At what time they crossed each other? Simple. 6 hours is what they require. From when? From 6 o'clock. Because the journey started at 6 a.m. and then 6 hours is required. What is the answer therefore? Therefore, the answer is 12 noon. Therefore, the answer is 12 noon, 12 p.m. 6 o'clock they started. 6 o'clock they started and they wanted 6 more hours. Therefore, the answer is 12 noon. By 12 noon, all they are meeting together and then they are proceeding to their destinations. Pretty simple question. Pretty simple question. Next one. I hope all of you got this delta concept, extra time concept. That is the extra time. Extra time after what? After meeting. The delta concept. Remember this. All right, I want you to remember this. I want you to remember this. This is a delta. All right, this is the concept of delta. Good. Okay, now let's go to the second point here. Listen to the same, under the same delta concept here. Let me illustrate here only. Let me illustrate here only. Hey, what is the speed of A? Hey, what would be the speed of A divided by speed of B? Under the same concept. Speed of A divided by speed of B. Speed of A divided by speed of B would be under root of delta time taken by B divided by delta time taken by A. Look, generally, if you know the total time, not the delta time, if you know the total time, how do you write speed of A by speed of B? How you would have written it here? Well, it's speed of A divided by speed of B. You would have written this as time taken by B divided by time taken by inverse proportion. This is what you would have written. Hey, what is the T and TB? T and TB is the total time taken by A and B. But this time what I'm giving you delta time, extra time. Extra time means after meeting extra time. If I give extra time, all you got to do is put a root. Don't write it as TB by TA, just like you wrote here. Hey, I'll write TB by TA. No, don't do that. The speed of A by speed of B would be under root of delta, extra time by this. Proofs are pretty simple. Don't bother about the proofs. Pretty simple. I want you to remember this. Good. Okay, go to the same portion. My point is simple. Whenever you get the delta, put it under the root. Whenever you get it delta, put it under the root. All right, delta part has to be kept under the root. That's it. All right, if you remember that much, you will never forget this. Okay, here we go. Do this question. I want you to answer this question. Answer this question. Guys, we are into the last leg, last 20-30 minutes of the discussion. Last 20-30 minutes of the discussion. Push yourself. It's a beautiful study. I enjoy time speed distance. It's a beautiful subject. You just have to be hands-on with your concepts. Yeah, answer this, friends. Answer this. I already gave you this. It hardly takes 30 seconds to answer this. Read the question. Answer it in 30 seconds. I guess you got this. Right, I gave a minute here just to assimilate the thoughts. Okay, here we go. So two vehicles A and B start from by same question, isn't it? So therefore let me put it to perspective directly. So what is that? So vehicle A, speed of A by speed of B. Or I do directly write it, speed of A by speed of B. What is A? A is going from Bangalore to Chennai, is under root of delta of time taken by B divided by delta time taken by A. What is delta? Extra time, right? Now, so one vehicle is taking 4. This is for A and 9 is for B. So therefore, put it to perspective, friend. What all is given here? SA is given. What is SA? 24. It's given. Therefore, write it 24 divided by speed of the vehicle B is nothing but under root of delta time taken by B. Extra time taken by B. How much? 9. What is extra time taken by A? How much? 4. Let extra time taken by A. How much? 4. Therefore, you will say that 24 divided by speed of B. Speed of B is also nothing but 3 divided by 2. Right? Therefore, you will understand that speed of B is nothing but 16. Speed of B is nothing but 16. Right? Yeah. Okay. Pretty simple one. Pretty simple one. Okay. Let's go further. Let's go further into them. Let's go further into them. There is one more concept, one more tiny concept that you may have to be mindful about. Let's take a look at this question now. Let's take a look at this question. X and Y are two places on a straight road which are 21 kilometers apart. P and Q start to walk simultaneously from X and Y respectively with the speeds of 3 kilometers per hour and 4 kilometers per hour respectively. Once they reach the other end, they turn back and keep walking between X and Y. Find the distance traveled by the faster person when they meet for the second time. Okay, just be a little mindful about this. What is this trying to say? It's pretty simple. So let me draw a line diagram to illustrate this. Okay, yeah, on a straight road which is 21 kilometers apart, the total distance is 21 kilometers. P and Q start walk simultaneously from X and Y respectively. So P starts here. P starts from point X. Let me write X and Y above. Q starts here. Q starts here with the speeds of 3 kilometers and 4 kilometers per hour. Once they reach the other end, they turn back and keep walking between X and Y. Find the distance traveled by the faster person when they met for the second time. It's a very important concept. I want to be a little mindful about this. What I do is, let me divide this, or let me divide this into 7 pieces. Let me divide this into 7 pieces. Just let me divide this into 7 pieces. Let me divide it. All right, now let me divide. So it here said that it's a 21 kilometers. 21 kilometers. I will divide them into 7 pieces, 7 blocks. 7 blocks. Just like that, I will divide 7 blocks. Okay, there are 7 blocks now. There are 7 blocks now. No worries. So I divided into 7 blocks. Now just take them as all it knows is 7 blocks. So by the time all it knows, so what is the ratio of the speeds here, friends, for both the fellows P and Q? right, for both the fellows P and Q. By the time he covers 3 kilometers per hour, Q can cover 4 kilometers per hour. Don't worry. First, follow my chalk. What I'm trying to say, follow my pen, which implies that by the time, instead of 3 and 4 kilometers, by the time P covers 3 blocks, by the time 3 covers 3 blocks, I can talk in terms of blocks as well. By the time P covers 3 blocks, Q will be able to cover 4 blocks. Q will be able to cover 4 blocks. All right, let us put it something like that. Okay, I will come to the point later. First, understand like this in the sense. All right, now remove this for 21, etc., etc. So when they meet, all right, now I gave them some time called T. I gave them a particular time called T. All right, first instance, I gave them a particular time called as T. In that time T, what happened is X traveled 3 blocks, which means he was here. Let me write those points here. Let me write it as A, B, C, D, E, F. F traveled 3 blocks. Solid. Now F is alright. X is at C. So time block. Where is X? Where is Y? Solid. Where is P? And where is Q? What I gave? I gave the first time interval. In the first time interval, some time I gave. So P traveled 3 blocks, which means he is at C. He is at C. By the time Q also traveled 4 blocks, because already the ratio of the speeds is 3 and 4. Therefore, I can talk in terms of blocks also. Alright, I can talk in terms of blocks also to help you to understand I'm doing this. To help you to understand I'm doing this. Forget that number 21 for the time being. Forget the 21 kilometers. Let's say that I divided into 7 blocks. By the time P travels 3 blocks, Q has the capacity to travel 4 blocks. So therefore, at the same time, what happened? The Q traveled. Alright, in the same time, Q traveled 4 blocks. Q traveled 4 blocks. This is one, second one, third one, fourth one. He traveled 4 blocks. All right, because that's his capacity. By the time P travels 3 blocks, or Q can travel 4 blocks. 4 blocks means what? Where is he? C. What happened? The first meeting happened. What about the meeting from here? The first meeting has taken place. They met once because the both are at the same point called C. So first meeting has taken place. Okay, give them the same amount of time, friends. Whatever you gave before, give them exactly same time. Give them exactly same time. If you give them exactly same time, P will travel 3 blocks, 1, 2, 3. He would be at F. He would be of F. Why? You give the same time. Therefore, he would travel 3 blocks. Absolutely. Give Q also same time. He will travel 4 blocks. What do you mean by 4 blocks? 1, 2, 3. He turns back. All right, he turns back because 3 blocks now. All right, it is 3 blocks. All right, this particular distance is 3 blocks. 1, 2, 3, 3 blocks. So therefore, from C, he went up to X, turned back and came to A. Turned back and came to A. That's 4 blocks. Came 4 blocks A. So where is this fellow? A. One fellow is at F, one fellow at A. So did they meet? No, no meeting took place. No meeting took place. Okay. Now go to the next time. Give them exactly again same time. Exactly same time. T1 is equal to T2 is equal to T3. If you give the same time again, all right, now in that case again, in that particular time interval, P is going to cover 3 blocks. Okay. What are the 3 blocks? First block, turn back. Second block, turn back. Third block, which means he is at E, which implies that this guy is at E. All right, this guy is at E. Okay, in the same time. So what happens to Q? He will travel 4 blocks. A to B, 1 block. B to C, second block. C to D, third block. D to E, fourth block. D to E, fourth block. Okay, in the sense both are at E. They met for the second time. Why I'm doing that? Because that's what author is asking. When they met for the second time, what is the distance covered by the faster person? That is the question precisely. Now look at this, guys. There are 3 full lines. If you look at this particular question now, there are 3 full lines. All right, there is 1 full line here. Who traveled does not matter. Who traveled does not matter. This is 1 full line here, and then further, all right, now further here, all right, now further here, and then you have little bit here. All this put together is 1 full line. All this put together is 1 full line. There is second full line here. There is also a second full line till here. All right, till here, and then all right, now somebody traveled this distance. Okay, and then somebody traveled this distance. This is second full line. Okay, there is a third full line also. All right, now from here till here somebody traveled, and then from here till here somebody traveled. 3 full lines. 3 full lines. But when they met for the first time, they both together traveled only 1 full distance. First time, all right, they took only 1 time interval. But when they met for the second time, they wanted double the time. Remember this concept. Whenever 2 people start simultaneously from the opposite direction, time required to meet for the first time, time required for the first meeting, all right, so sorry, distance traveled for the first meeting, all right, distance traveled for the first meeting distance to be traveled to meet for the first meeting is nothing but 1 full length, just 1 full distance they should travel. However, when they want to meet for the second time, All right, between the first and the second time, they got to travel additional 2D distance. Additional 2D distance. So that's what happened there. Say, why 3 distance have happened? Did they travel 1.5 distance to meet for the first time? Absolutely not. To meet for the first time, they just traveled 1 full distance. See, all right, this is what P has traveled first time, black line. This is what Q has traveled. They met for the first time. That is what happened there. But to meet for the second time, they covered twice the distance. Covered twice the distance. Okay, similarly, you may say that, hey, to meet for the third time, what should happen between the second and third meeting? They have to cover extra 2D distance. Hey, when this is possible, speed of the faster person divided by speed of the slower person, speed of the faster person by speed of the slower person should lie between, or it should lie between 1 and 2. Whenever the speed of the faster person and the speed of the slower person lies between 1 and 2, this concept is true. This concept is true. To meet for the first time, together they will cover 1 full distance. After that, for every additional meeting, or they require 2D distance. They have to cover 2D distance to cover. Now this is the point I want you to understand. When it is true, speed of the faster person by speed of the slower person should lie between 1 and 2, including 1 and 2. All right, should lie between 1 and, all right, should lie between 1 and 2, including 1 and 2. All right, now that is the point there. All right, this point I want you to remember. This point I want you to remember. All right, this is the point I wanted to make in this question. Okay, let's come back to this question. Therefore, let's come back to this question. Let's come back to this particular question. Okay, so now what is the question here? When find the distance traveled, find the distance traveled by the faster person when they meet for the second time. When they meet for the second time, they will be covering a distance called 3D. The total distance covered by both of them, total distance covered by both of them, total distance covered by both of them is going to be 3D. What is the difference? 21. Well, D is 21. Why? First time they have to cover D distance. For the second meeting, they have to cover 2 distance. What is the total distance? Therefore, the total distance is nothing but 3D. Okay, 3 times of 21. That is the distance. All right, distance they have traveled together is 3 times of 21. All right, 3 times of 21. All right, which is 63 meters. Correct. Now, how did they travel? They would travel in the ratio of their speeds because the time is constant. See, I'm coming to the question where time is constant. How long did they travel to meet for the second time? Constant time. If the time is constant, then the speed and the distance are directly proportional. Then the speed and distance are directly proportional. They'll be in the same direction. All right, now speed of the A and speed of B, and the solid is therefore speed already A and B. Speed and distance are directly proportional. Speed and distance are directly proportional. Hey, what are the speeds of A and B, friends? What are the speeds of A and B? You know, A and B only, right? No, not A and B, P and Q. What are the speeds of A and P and Q here? Speeds of P and Q given 3 and 4 respectively. 3 and 4 respectively. Therefore, what is the distance? Distance will be 3x and 4x. Hey, what is 3x and 4? What is the total here? Total is 7x. Hey, what is 7x is equal to, because this you use the adjective. Remember the adjective that you use, total. If you use the total, you use the total here also 7x. Hey, what is 7x? 7x is equal to 63. Hey, what is that 63? This is 63. What I should do with this 63? Divide it in the ratio 3x and 4x. 7x is equal to 63. Therefore, x is equal to 9. If x is equal to 9, find the value of 3x here. Therefore, 9 into 3, 27. Yeah, what 9 into 4, 36. Faster person, how much did he cover? 36, which is your answer. 36 is your answer. I hope all of you got this particular point. Pretty simple one. Pretty simple one. I want you to be mindful about this concept. See, these are the tiny concepts that you should remember. This what gives you the speed. You can't say that, okay, I don't know this concept. If the speeds are between this and this ratio, then I don't know that it is going to be A plus 2D plus 2D. Then you're ignorant about them. Then you will not generate the speed. Hey, what if it is not? That we will think later. Hey, what if it is not between 1 and 2? Can't they give a question? It is not between 1 and 2. They can give a question which is not between 1 and 2. They may give a question. Then how do I solve it? Okay, so what I meant here, now look at this. This is the test that you do. 4 by 3, right? Speed of the faster person. This check you should do. What is the speed of the faster person? 4 kilometers per hour. What is the speed of the slower person? 3 kilometers per hour. Hey, does this lie between 1 and 2? Yes. Yes. Therefore, I can apply this concept. I hope all of you got this. Do another question, friends, quickly. Do this question. All right, if you understood this concept quickly, I'll let you put this question to perspective. Same question, put it to perspective. Same question it is, right? Here we go. This question. Put it to perspective. Quickly put it to perspective, my friends. Do it. I'm watching. Do it quickly. I'm sure you might have done, but now, yeah, let's do this. Okay, what is it talking about here? 150 is the distance between x and y. So you can draw the line diagram, you can draw without line diagram, also does not matter. So by now you know the concept. Yeah, what is the distance between them? This. Okay, what is the ratio of the speeds? 3 by 2. Speed of already x and y are two places away, A and B. Speed of the faster person, speed of the slower person. So what is that? 3 by 2. Is 3 by 2 lying between 1 and 1 and 2? Of course, yes, it's 1.5. Ratio of the speeds is 1.5. Therefore, condition is fine. When they meet for the fourth time, right? When they meet for the first time, the distance covered is d. When they meet for the second time, another 2d. When they meet for the third time, another 2d, right? When they meet for the fourth time, another 2d. Therefore, what is the total distance traveled, friends? Total distance. Total distance. Let me call it as d. Total distance d. Total distance is all these numbers, which is 70. 7, now 70 is the total distance traveled. What is the value of d? 150 meters. 150 meters, right? Yeah. So therefore, already you will say that 7 into 150, that is 1350. Right? Sorry, 1050. Okay, 1050. 1050 is the 1050 meters is the total distance traveled. Okay, say what about these two folks A and B? What about these two folks A and B? The speed ratio is given. The time is constant. Yeah, all these fellows were walking for the same time. Yes, yes, both fellows A and B all right now going between the two ends X and Y. All right, for that entire time of duration. Therefore, what is constant? Speed, time is constant. If the time is constant, then speed and distance are directly proportional. Yeah, what is the ratio of the speeds? 3 is to 2. Therefore, what is the ratio of the distance? 3x and 2x, direct proportion. If it is 3 and 2, then you better write the same thing here, 3 and 2. Okay, therefore, what is the total, friends? Total is nothing but 5x. If 5x is equal to what? 1050. Because total, if you are rewriting the total here, you added all this and you wrote the total here. If you wrote the total, you better write the total here also. Therefore, 5x is equal to 1050. All right, 5x is nothing but 1050. So the question here is what? What is the distance traveled by the faster person? Therefore, 3x is equal to what? 3x is equal to what? Because the distance traveled by the faster person is how much? 3x. Hey, should I find x? Not required. Directly find the answer. 5x corresponds to 1050. Therefore, 3x corresponds to how much? That is also fine because x is irrelevant. It is not that I should find x before I get the answer. Absolutely not. All right, absolutely not. Right? Yeah. Therefore, it is nothing but 210 into 3, which is nothing but 630 meters. All right, the faster person would have covered a distance of 630 meters. Okay, that's this particular question. One last question type we will do and we will wind up. Right, one last question type, then we will wind up. One last question type, and then we'll wind up. We'll take the rest of it in the second lecture. Right, we'll take the rest of it in the second lecture. Think about this. I'll give a minute. I want you to think about this. We are in the application phase now, but sadly we are running out of time. So we'll do a couple of applications. One last type of application we'll do. Then we'll take up rest of the applications in the next lecture. Okay, so at least you have read the question. Do it with me. Do it with me. This is what is happening. Assume that the dog has seen this, or a dog has seen his owner. The dog has spotted the owner. The man is here. The man is here. It spotted the man there. The dog kennel is here. The dog house. The house of the dog is here. That's a kennel. Right? So this is the dog house. The dog spotted it from there. That's a kennel. So it's at the home. So now it wanted to let no surprise him, do something with him. So the distance is total is 100 meters. Total distance is 100 meters. Yeah, what is the speed of the man? 5 meters per second. First, what is constant here? Time is constant. Basically, I'm doing a couple of application on time constant, friends. That is it, no big deal. So time is constant. Yeah, what do you mean by time constant? The time for which the man takes to travel this 100 meters is same as the time for which the dog is going to be active at the speed of 15 meters per second. See, technically what this dog is trying to do is it spots the man. Assume that this point is this point is P. This point is P. It spots the man at P. It runs. All right, it meets the man at Q. Man has come till here. At that point in time, the dog has traveled till here. All right, it met him at Q. Then it turned back and went. It turned back and went back to this particular house. Okay, that is the first journey. That's the first leg. Second time, all right, by the time it turned back and came, the person was at R, let us say. The person was at R. So therefore, the dog came till here, or a dog came till here, and it went back. and it went back. That's the second leg of journey. Next time, all right, now the man was at yes. Let's assume that the man was at yes. What did the dog do? Dog came till yes. All right, by the time dog turned back and came, the man was at yes. So therefore, all right, now the dog went back. Like this journey is going on and on and on. That's a point here. That's a point here we are trying to make. Hey, what is the constant thing between the both of them? Time is constant. Time taken by the man to cover 100 meters at the rate of 5 meters per second is same as the distance. All right, that is the same time the dog was active with a speed of 15 meters per second. Both of them are same. Therefore, time is constant. Great. That's it. Therefore, the time is constant. Fine. Therefore, what is the time taken? All right, what is the time taken by man? What is the time taken by man to reach the destination? 100 meters. All right, what is the distance here? Distance is 100. Excuse me, friends. Excuse me. Yeah, thank you. Okay, time taken by the man. What is the distance here? 100 meters. What is the speed with which the man is traveling? 5 meters per second. What is the speed with which man is traveling? 5 meters per second. Therefore, how long this man will be traveling? 100 divided by 5, 20 seconds. This man will be traveling for 20 seconds. Therefore, the dog was also active for 20 seconds. All right, therefore, what is the distance? Total distance traveled by the dog. The total distance traveled by the dog. Total distance traveled by the dog is speed into time. What is the speed? 15 meters per second. Speed of the dog is 15 meters per second. What is the time taken by the dog? 20 seconds. Why? Because the dog was also active for 20 seconds. Therefore, time taken by the dog is 20 seconds. Okay, therefore, what is the total distance traveled by the dog? 20 into 15, all right, which is nothing but 300 meters. The dog has traveled a total distance of 300 meters. That's what you are trying to say. Dog has traveled a total distance of 300 meters. Out of this 300 meters, all right, out of this 300 meters, right, it has traveled a total distance of 300 meters. Out of this 300 meters, half the distance will be in the forward direction. What is forward direction? Forward direction is kennel towards owner. That's a forward direction. So assume this is a forward direction here. I'm putting a hash. This is the forward direction. This direction is forward direction. So as much as it went forward, the same backward green line is there. The same backward green line is there. As much as it traveled forward, exactly same red line backward is there. It has to be, because it has to reach back the kennel. Similarly, the black line, as much as it traveled forward, it is exactly the same distance the dog has traveled backward. Therefore, it is 50-50. Therefore, the distance traveled by the dog in the forward direction is 300 divided by 2. Is 300 divided by 2, which is 150 meters. That is the answer. All right, that is the answer. Firstly, what was the concept behind this particular question? First concept behind this question was time is constant. Time is constant. Time for which the dog was active and the man was traveling was constant. All right, that's the first point there. All right, that is the first point. From there, everything evolves. What is the second point there? The distance traveled by the dog in the forward direction is same as the distance traveled by the dog in the backward direction, because the distance won't shrink the moment the dog start going backward. It is the same distance. Whatever it traveled forward, it has to travel backward. Right now, let's take one beautiful question built on the exact concept and we'll wind up. We'll close with that. Beautiful question on the same concept and we'll close it. All right, now the last question was a build up to do this particular question. It's a build up to do this question. Let's do this question, then we will stop. Fine, guys, do this question. Quickly do this question, all of you. Okay, do it with me. So what has happened is, this time the diagram is something like this. There's uphill, something like this. The kennel is here. This time the kennel is kept here. The dog starts here. The dog starts here. The man is spotted somewhere here. Here is the man. The man is spotted somewhere here, going upward. The man is going upward. All right, this is the positions of the dog and the man. So therefore, all right, now the dog, naturally, because it's uphill, it cannot run back at the same speed. Very natural. All right, very natural. Therefore, when the dog is coming down, downhill speed is given. All right, downhill speed is 30 meters per second. Downhill speed is 30 meters per second. It can run little faster. But when the dog is trying to go up, green line is for dog, right friends? When the dog is trying to go up, it can go up with a speed of 20 meters per second. But the distance what it travels in the first leg of journey will remain constant. First of all, time is constant, very same question, just that the speeds are varying, exactly same, everything else remains same. 2 points I made in the previous question. What was the point number one? Time of journey is constant, both for the dog as well as for the man. Hey, what is the second thing constant? The distance traveled by the dog down the hill is same as the distance traveled by the dog up the hill. That's it. All right, that is also not going to change, because the hill will not shrink by the time dog returns to do the return journey. It remains same, both remain same. Now there is a third parameter I'm trying to bring in here. That's it. There is a third parameter that I'm bring in here. All right, bring in here. Now look at this. All right, now so one, the time is constant. Let's find out what is the time taken by the man. Time constant. Good. We found out that the time is constant. And therefore, what is the time taken by the man to complete this particular journey? Same time, 100 divided by 5, 20 seconds. It's the same time, 100 divided by 5, which is the 20 seconds. Therefore, the dog was also active for 20 seconds. But the point here is, find the total distance traveled by the dog when the owner reached this particular kennel, right? Okay, the total distance traveled by the dog. So how do I write it? Okay, distance traveled by the dog. Distance traveled by the dog is nothing but speed into time. Right now, time I know, time is 20. Speed, all it now, time into speed. For time, I will write 20 seconds, because 20 seconds dog was also active. But the point is, which speed I should write? Should I write 30 or 20? No, you have to write the average speed. You may wonder, why average speed? Because the distance is constant, friends. Distance traveled by the dog in the forward journey is same as the distance traveled by the total distance traveled by the dog in the forward journey is same as the total distance traveled by the dog in the return journey. If the total distance traveled by the dog in the forward and return journey are same, all right, if both of them are same, all right, then the speed is going to be the average of the speeds. That's what we understood there. Average of the speeds, harmonic average of the speeds. If the distances are constant, so what is distance here? Total distance in the forward journey is same as total distance in the return journey. Therefore, what is the speed here? Average speed. Average speed. When the distance is constant, I already said that average speed is nothing but the harmonic mean of the speeds. That's how you use it here. Okay, therefore, what is the average speed here? Average speed. Average speed is nothing but 30, or 2ab, that is 2 into 30 into 20. 2 into 30 into 20. Downward speed, downhill is 20, uphill is 20, downhill is 30, uphill is 20, divided by 30 plus 20, divided by 30 plus 20. All right, divided by 30 plus 20. All right, yeah. Okay, so therefore that would become how much? All right, that's 24 kilometers per hour. All right, therefore the average speed is 24. You write this as 24. Therefore 24 into 2, 480. 480 meters is the total distance traveled by this particular dog. All right, that is the total distance traveled by this particular dog, which is nothing but 480 meters. All right, that is 24 into 20. That is what you are writing here. Perfect. All right, now that's 480. So that is the answer to the first question. Find the total distance traveled by the dog when the owner reaches the kennel. 480 is the total distance traveled by the dog. If I ask you here, hey, what is the distance covered in the forward journey? Distance covered in the forward journey, half of it, 240. Hey, what is the distance covered in the return journey? That is also half of it, which is 240. Look at the next question. Find the total time for which the dog run down the hill, which means what is the downward hill time? All the totals of all the time, the downward hill time. You can't say that, hey, 10 seconds, wrong answer. If you say that, okay, out of this 20 seconds, 10 seconds was downhill and 10 seconds was uphill, then you are wrong. Why? Because downhill it was going with the faster speed. Downhill was always faster, uphill was always slower. Therefore, naturally it would have taken more time to travel uphill, because it has to cover the same distance. So therefore, now what is the concept you are talking about? Hey, distance is constant. Downhill distance is same as uphill distance. That's what you mean by distance is constant. What is distance constant here? The downhill distance, total distance covered downhill, is same as total distance covered uphill. Distance is constant. If the distance is constant, speed and time are inversely proportional. That's what you are trying to say. Speed and time are inversely proportional. Hey, what is the downhill speed? There is a downhill speed and there is a uphill speed. Hey, what is the downhill speed? 30 kilometers, 30 meters per second. Hey, what is the uphill speed? 20. Therefore, what is the time taken? Reverse, inverse, they have this. That is 2:3. 2x time and 3x time. Yeah, what is the total time? Therefore 5x time. 5x time is equal to how much? 20 seconds, because the dog has traveled for 20 seconds. Therefore, what is the value of x? 4. Value of x is what? 4. X is 4 means what? 8 seconds was downhill, 12 seconds was uphill. Already 8 seconds was downhill and 12 seconds was uphill. Beautiful question, pretty beautiful question. Solid. Now in the same question, at some time you are using time is constant. In the same question, you are also realizing and using distance constant. In the same question here also you use the relative distance constant. Because you use the distance constant, you wrote the relative average speed as the harmonic average of the speeds. Beautiful question, summarizes a lot of things. Beautiful cat question it was. Right now here we go. So this is the thing. This is the thing I wanted to discuss today. I will sure discuss much more applications when I take the time, speed, distance too. I hope everybody enjoyed this lecture in the sense you learned through this particular lecture. Stay safe, stay safe. Let's stay focused. I will see you in the next lecture, with the further elements of the time, speed, distance. Stay blessed. I will see you then. Bye till then.